minute. One of our leaders in Taiwan Andes technology, one of the first RISC-V vendors to pass many of the safety and security standard protocols that we have seen across the automotive industry. This has enabled lots of great partnerships with Renesas, Andes, Sci-Fi, and Andes coming out with very competitive, differentiated IP to solve those performance challenges.
Today's solution comprised silicon plus software and also software as a service. Very few companies have the experience and capability as Intel in silicon plus software. To bring the systems foundry approach to life, we will lead with a software-first mindset at every layer. And we are bringing some of this leadership to RISC-V.
Powerchip Semiconductor Manufacturing Corporation, PSMC, in Hsinchu Science Park, Taiwan. Positioned as a professional wafer foundry service provider with massive production capacity of 12-inch and 8-inch wafers, we have made huge strides forward in the global landscape of the semiconductor industry, upholding our corporate culture of integrity, excellent service, high quality, and innovation. We are committed to empowering Taiwan's high-tech industry at its core and devoted to the development and manufacturing of cutting-edge semiconductors. Our technology enables constant innovation of new products and applications, with new ideas emerging all the time. Currently, we are researching developments in artificial intelligence, AIoT, big data, 5G communications, and other applications such as automotive electronics. As we expand to future technologies, PSMC proudly upholds our mission to create a win-win outcome for our loyal and valued clients. We aim high and strive for perfection in the semiconductor industry. Powerchip Semiconductor Manufacturing Corporation.
Optimizer's software-defined LLM SoC architecture and AI runtime engine makes on-device inferencing and training possible. It is optimized for SOTA fine-tuned models and domain-specific AI applications. We focus on production-grade AI LLM deployment on all edges with compiler-level software stack and tools. ONNC compiler targets on diverse SoC architectures from a simply single-core system to a heterogeneous system with multi-level memory hierarchy and bus connection. Forest Runtime executes compiled neural network models on the hardware platform of your choice. Forest Runtime is retargetable. It has modular architecture, and we've ported it on diverse hardware platforms, including data center, mobile, and TinyML. ONNC Calibrator leverages hardware architecture information to keep AI system on chips in high precision through the post-training quantization technique.
With the rise of the personal computer, UMC was at the forefront of IC innovation, shaping an interconnected world. When humans dreamt of taking flight, UMC was there, transforming hope into reality. In the coming future, UMC aims to deliver semiconductors with higher performance and energy efficiency.
这个 RISC-V 它在 AI 在 HPC 各方面，事实上它没有什么实际的 limitation。那可能因为大家最熟悉的就是它是 open source， 所以它的这个 instruction set 自己可以自由可以扩张啊，进展会非常的快，在很多领域它的自由度非常的高。
So let's talk about Taiwan for a minute. One of our leaders in Taiwan and its technology, one of the first RISC-V vendors to pass many of the safety and security standard protocols that we have seen across the automotive industry. This has enabled lots of great partnerships with Renesas, Andes, Sci-Fi, and Andes coming out with very competitive, differentiated IP to solve those performance challenges.
Today's solution comprised silicon plus software and also software as a service. Very few companies have the experience and capability as Intel in silicon plus software. To bring the systems foundry approach to life, we will lead with a software-first mindset at every layer. And we are bringing some of this leadership to RISC-V.
Powerchip Semiconductor Manufacturing Corporation, PSMC, in Hsinchu Science Park, Taiwan. Positioned as a professional wafer foundry service provider with massive production capacity of 12-inch and 8-inch wafers, we have made huge strides forward in the global landscape of the semiconductor industry, upholding our corporate culture of integrity, excellent service, high quality, and innovation. We are committed to empowering Taiwan's high-tech industry at its core and devoted to the development and manufacturing of cutting-edge semiconductors. Our technology enables constant innovation of new products and applications, with new ideas emerging all the time. Currently, we are researching developments in artificial intelligence, AIoT, big data, 5G communications, and other applications such as automotive electronics. As we expand to future technologies, PSMC proudly upholds our mission to create a win-win outcome for our loyal and valued clients. We aim high and strive for perfection in the semiconductor industry. PowerChip Semiconductor Manufacturing Corporation.
SkyMiser's software-defined LLM SoC architecture and AI runtime engine makes on-device inferencing and training possible. It is optimized for SOTA fine-tuned models and domain-specific AI applications. We focus on production-grade AI LLM deployment on all edges with compiler-level software stack and tools. ONNC compiler targets on diverse SoC architectures from a simply single-core system to a heterogeneous system with multi-level memory hierarchy and bus connection. Forest Runtime executes compiled neural network models on the hardware platform of your choice. Forest Runtime is retargetable. It has modular architecture, and we've ported it on diverse hardware platforms, including data center, mobile, and TinyML. ONNC Calibrator leverages hardware architecture information to keep AI system on chips in high precision through the post-training quantization technique.
With the rise of the personal computer, UMC was at the forefront of IC innovation, shaping an interconnected world. When humans dreamt of taking flight, UMC was there, transforming hope into reality. In the coming future, UMC aims to deliver semiconductors with higher performance and energy efficiency.
这个 RISC-V 它在 AI 在 HPC 各方面，事实上它没有什么实际的 limitation。那可能因为大家最熟悉的就是它是 open source， 所以它的这个 instruction set 自己可以自由可以扩张啊，进展会非常的快，在很多领域它的自由度非常的高。
So let's talk about Taiwan for a minute. You know, one of our leaders in Taiwan and its technology, one of the first RISC-V vendors to pass many of the safety and security standard protocols that we have seen across the automotive industry. This has enabled lots of great partnerships with Renesas, Andes, Sci-Fi, and Andes coming out with, very competitive, differentiated IP to solve those performance challenges.
Today's solution comprised silicon plus software and also software as a service. Very few companies have the experience and capability as Intel in silicon plus software. To bring the systems foundry approach to life, we will lead with a software-first mindset at every layer. And we are bringing some of this leadership to RISC-V.
Powerchip Semiconductor Manufacturing Corporation, PSMC, in Hsinchu Science Park, Taiwan. Positioned as a professional wafer foundry service provider with massive production capacity of 12-inch and 8-inch wafers, we have made huge strides forward in the global landscape of the semiconductor industry, upholding our corporate culture of integrity, excellent service, high quality, and innovation. We are committed to empowering Taiwan's high-tech industry at its core and devoted to the development and manufacturing of cutting-edge semiconductors. Our technology enables constant innovation of new products and applications, with new ideas emerging all the time. Currently, we are researching developments in artificial intelligence, AIoT, big data, 5G communications, and other applications such as automotive electronics. As we expand to future technologies, PSMC proudly upholds our mission to create a win-win outcome for our loyal and valued clients. We aim high and strive for perfection in the semiconductor industry. Powerchip Semiconductor Manufacturing Corporation.
Optimizer's software-defined LLM SoC architecture and AI runtime engine makes on-device inferencing and training possible. It is optimized for SOTA fine-tuned models and domain-specific AI applications. We focus on production-grade AI LLM deployment on all edges with compiler-level software stack and tools. ONNC compiler targets on diverse SoC architectures from a simply single-core system to a heterogeneous system with multi-level memory hierarchy and bus connection. Forest Runtime executes compiled neural network models on the hardware platform of your choice. Forest Runtime is retargetable. It has modular architecture, and we've ported it on diverse hardware platforms, including data center, mobile, and TinyML. ONNC Calibrator leverages hardware architecture information to keep AI system on chips in high precision through the post-training quantization technique.
Good afternoon, everyone. Our event will begin in 3 minutes. Please take your seats promptly. To ensure the quality of the event, may we remind you to switch your phone to silent mode. Thank you very much. Good afternoon, ladies and gentlemen. Our event is about to begin. Please take your seat promptly. Thank you very much. Good afternoon, everyone. Our event is about to begin. Please take your seat. Thank you.
Good afternoon, everyone. On behalf of RISC-V Taiwan Alliance, I welcome everyone to attend this 2023 RISC-V Taipei Day. I am Frank Lin, currently the chairman of RISC-V Taiwan Alliance. Today, I'd like to share the topic as the kickoff of our today's conference. RISC-V is incredible. This is the era of open standard and collaboration. RISC-V is an open standard we set for open computing. RISC-V International Association is set for this purpose. Also, RISC-V Taiwan Alliance. It's all about strategic to hardware and software design across industries and academy, including worldwide geographies. So we like to name RISC-V as the definition of open computing. We see that RISC-V is the most prolific and open instruction set architecture in the history. So I said, RISC-V is incredible. It is inevitable. You could use RISC-V, apply it to every kind of application. It can enable the best processors, which I will cover later on. And it is now a mature ecosystem. So our mission is to make RISC-V the industry standard. Well, I like to say it is being reached. My personal observation is that RISC-V x86, together with ARM architecture, are now 3 major industry standards in the world. More than 10 billion RISC-V cores have been shipped. I'll give you an example later on. So many kind of innovation and adoption has been adopted and moved the RISC-V promotion to another category. The demand at different kinds of performance level, from entry level to the very high-end application, are all there. from all over the world, so much investment from very kinds of companies, associations, governments, and academy has shown this investment reaching billions. There is a statistic in Siemens that nearly a quarter of designs incorporate RISC-V. This investigation has done in 2020. Now it is 2023, so I guess it's more than that now. RISC-V leads on innovation. There are three perspectives. Let me share it with you. First, domain-specific extension. You could add your custom instruction set on top of the modular instruction sets. The instruction set modules could not be changed without approval from RVI. However, your engineer team could do your custom extension design with the specification interface defined by RVI. So there's a so-called domain-specific software and vendor-specific extension for you to develop. Also, RISC-V is doing platform standardization. I'll give you very details later on. And it is building a contributor culture. So all these alliance association in the slide, you could see, actually we are doing similar kinds of contribution as a culture like them. This is the slide, perhaps the most technical in-depth that I will share with you today. This slide made the statistics on the ratified spec or ISA in years 2021 to 2023 year to date. From that, I'd like to show you that let's take a look at the list in 2021. Some of them are more important from my personal view, so I label them with red color. For example, for AI, vector extension is so important because it can help you to do matrix manipulation, multiplication, and so on. Cryptography extension, that can help you apply RISC-V to IoT or AIoT. Bit manipulation help you to reduce the code size and make the system or the chip smaller. Hypervisor, very important. With that, RISC-V can enter the application of a virtual system, so more and more application could be possible. For example, Android porting, or in the future, perhaps iOS or further porting. In 2022, wait for reservation set. In 2023, year to date, I like to emphasize the part of RISC-V profiles, RVA 20, RVI 20, and RVA 22. With these, we will see in the future, RISC-V could be applied to further focused application, for example, mobile phone, and so on. RISC-V enables the best processors. I'll give you example. For them to do processor design with RISC-V and provide to public, NDs, Sci-Fi, Codasip, T-Hat, MIPS, Imagination, you name it. In-house, they design these processors in RISC-V and used by themselves. For example, Seagate, Western Digital, NVIDIA, MediaTek, and another big design house in Taiwan, Tenstorrent, Ventana, Esperanto, Revos, Huawei, S-Wing, and so on. So there are quite many worldwide companies, institutes, universities, organizations, they are adopting RISC-V architecture and move forward. Intel, for example, IFS, Intel Foundry Service, put a lot of investment in RISC-V. They named $1 billion innovation fund to put as investment you could apply if you adopt RISC-V in your organization. You could try to, or if you are a startup, you could try to apply that capital. Intel IFS aggressively involved in RVI roadmap and cultural development and future development. So it is now a board member in RVI. Another example, Qualcomm. In Qualcomm, they have a white paper showing that they especially emphasize 3 main advantages from RISC-V: flexibility, control, and visibility. So Qualcomm has been heavily involved in RISC-V RVI operation management, also governments. Another one, RISC, which I'll give you details later. Qualcomm is also involved in that. I have another example coming soon. So Qualcomm has been adopted RISC-V in their product design since 2019. To date, Qualcomm already shipped more than 650 million chips with RISC-V built in. And now, starting 2 months ago, Qualcomm representative Lu Dai became the RVI board chair. We will have his speech later on. One another example, Google. By December 2022, in the summit of RISC-V, Google came to make an announcement that Google formally support RISC-V with Android. So this is the subject they did Keynote. You could do research, do search in Google search. Yeah, you can try to retrieve that the video and take a look at it. So Google is called for proposal, call for board, even call for chip design for test chip that can combine RISC-V and Android. One example, NT is doing its NT Core that can accommodate Android application and coming soon. Here's another example I like to show you that Qualcomm involved. I guess perhaps you already read the news. Five Giants Alliance. In Taiwan, they call it the Five Eyes Alliance. Qualcomm, Bosch, Infineon, Nordic, and XP. But to be honest, up to today, I am not sure, are they designing RISC-V CPU only or RISC-V-based architecture SoC? Maybe both, maybe one of them. Let's read it. I quote from their announcement. This newly formed company's initial focus will be the development of a fully certified RISC-V-based IP and architectures and the creation of a one-stop ecosystem where customers can select the turnkey assets. From the quote, personally, I believe it's a chip level that will goes to ISO 26262 kind of a certification. Okay, so more about RVI, RISC-V International Association. In 2022, the membership of RISC-V already grew 30% to more than 3,800 RISC-V members. That's a group member, with individual members also more than 3,000. Many chips, I/O services, systems, and applications have been deployed. This page, I'd like to show you in data center and cloud computing, how RISC-V reached its achievement. From Milk 5, Imagination, Esperanto, Untethered AI, Mentana, TensorRent, they all have application in their category by applying RISC-V. Also, MTIA, they made announcement in a conference second quarter that MTIA V1 AI inference accelerator, the scalar and the vector are from ND's RISC-V processors. Okay, in this slide, I'd like to share with you RISC, RISC-V Software Ecosystem. This is the initiative to accelerate RISC-V software ecosystem. In that, Qualcomm and others you could see from all over the world already joined as members, and the board has been kicked off. I also like to tell you that every one of you, talents, experts, you are welcome to join in our RISC-V Taiwan Alliance. We already have more than 60 members in Taiwan, and in this alliance, we will try to help Taiwan's industry ecosystem, supply chain, value chain to gain from RISC-V advantages. So RISC-V is ready now to contribute to semiconductor, ICT, OEM, ODM, EMS, and the system industries in Taiwan. And you should plan how to make a fortune for your own, for your company, for your organization through RISC-V. And that is my conclusion for today's kickoff. Thank you.
Thank you. Thank you so much. What a great way to start our event. Let's give a big round of applause again to Mr. Frankwell Lin, Chairman of RISC-V Taiwan Alliance and Chairman and CEO of ND's Technology. Thank you. Good afternoon, ladies and gentlemen. This is Sam, your host for today. Welcome to the IC Tech in the AI Era Forum 2023 RISC-V Taipei Day. On behalf of the organizers, we'd like to extend our thanks to those who joined us in the morning session, The Journey of AI Computing in Taiwan, Challenges and Opportunities. Now let's dive into the discussion and unlock the possibilities of RISC-V in the AI era. Together, we will explore the role of RISC-V in AI computing and learn how the RISC-V open source processor architecture can empower complex IC systems and AI computing architectures in the AI era. First and foremost, it is our great honor to have Dr. Zhipeng Li, Director General from the Department of Engineering and Technologies, NSTC, with us today. Let's welcome Dr. Zhipeng Li to give us a few words. Welcome, Dr. Li.
Dr. Alex Wang, Chairman of Taiwan IoT Technology and Industry Association, and Mr. Frank Welding, the Chairman of RISC-V Taiwan Alliance, and Mr. Zhengsheng Huang, and Dr. Tianfu Chen, the Vice Chairman of the RISC-V Taiwan Alliance, and all participating executive committees of the RISC-V Taiwan Alliance, RVTA, our distinguished speakers and guests from the industry. And ladies and gentlemen, good afternoon. It is my great honor to be invited to this 2023 RISC-V Taipei Day as part of the IC Tech in the AI Era Forums organized by RVTA, IEEE CASIF Taipei, and the Tierra. On behalf of the Department of Engineering and Technologies, National Science and Technology Council, I would like to thank you for your warm and kind invitation. We all know that AI has reached a critical inflection point. Large language models have attracted great attention recently and require a lot of calculations for the AI modeling and inference. This gives RISC-V a good opportunity because RISC-V can provide powerful and flexible building blocks to realize complex AI computing architecture. As far as I know, the RISC-V Taiwan Alliance was initiated and established in early 2019 by Dr. Frank Huang, the chairman of Power Chip Group, to leverage the opportunity from open source architecture for IC design industry. It is truly admirable. Of course, we should also thank the industry leaders such as Dr. Alex Huang of the Power Chip Group and Mr. Frank Welding of the Andes Technology, and other pioneers for their selfless efforts in promoting and assisting the development of Taiwan RISC-V ecosystem. Today, RVTA has more than 60 business members, and the total number of members has grown to more than 400, including individual members. Over the last 6 months, we have seen global IT and the semiconductor giants express their intention to join the RISC-V ecosystem. For example, Meta will launch its first customized AI chip in 2025, and the Google will also announce that Android will support the RISC-V architecture in the future. On top of that, major chip manufacturers such as Qualcomm, NXP, Infineon, and Bosch, Nordic have also joined forces to drive the expansion of the RISC-V ecosystem. With all these investments in RISC-V, we can see a complete hardware and the software system that will drive the supply chain of Taiwan IC design industry to invest R&D resources in the development of their turnkey products. Here, I would like to express my special thanks today to the speakers and the distinguished guests. You are all pioneers who have made a great contribution to the development of RISC-V. I hope we will continue to have more technical exchange activities, and that the scale continue to grow with the annual RISC-V Summit. Last but not least, on behalf of the Department of Engineering and Technology, National Science and Technology Council, I would like to once again thank the RISC-V Taiwan Alliance for your continuous efforts in encouraging innovative technology in the IC design industry. I look forward to the success of today's event, and I wish you all the best and health. Thank you.
Thank you very much, Dr. Zhipeng Li. Thank you so much for your welcome remarks. Okay, next I'd like to invite Dr. Alex Wang, Chairman of Taiwan IoT Technology and Industry Association, one of the organizers, to say a few words to us. Welcome, Doctor.
Directly from National Science and Technology Council, Chairman Lin from Taiwan RISC-V Association Alliance, and the distinguished speakers and the guests, welcome and good afternoon. 4 years ago, 2019, Taiwan RISC-V Alliance was established to promote this open source standard as a ecosystem. Today, I'm mostly, I feel gratified that that vision has already mostly realized. Now, as I think Franklin already indicated, it's a mainstream computing architecture. So giant company like Qualcomm and Google are all doing RISC-V. Today, this year, our Taipei Day theme is, as you know, is RISC-V in AI. I think we have all heard enough about AI, why it's important. But why RISC-V? Why do we need RISC-V for AI? Don't we have many other options, or at least a few options? Well, yes or no. In my opinion, or my personal expression, I like a very simple indication from Hans Thoren that in AI acceleration and certain HPC, you really need to deal with certain data types and other existing computing standards. They just are not making available. Whereas we know the RISC-V IP company are willing and able to provide. And that is very important if you want to do a very optimized AI. So with that background and the blessing, I wish today's event a great success. Thank you.
Thank you, Dr. Wang. Please remain on stage. We're going to have a group photo session. Yes, thank you so much. Today is truly excited that we have so many distinguished VIPs in the RISC-V fields here. Let's take this chance and take a memorable group photo together. Could the following honored guests please step forward when I call your name? First, we'd like to welcome Mr. Frankwell Lin, Chairman, RISC-V Taiwan Alliance. Dr. Zhipeng Li, Director General, Department of Engineering and Technologies, NSTC. Dr. J.S. Huang, President, Syntronics Corporation. Dr. Tianfu Chen, Associate Dean, Professor, Department of Computer Science, National Yangming Jiaotong University. Dr. Philip Tomsey, Technologist and Founder, Bureau. Mr. Wei Han Lian, Chief CPU Architect and Senior Fellow Architecture, Tenstorrent. Dr. Charlie Su, President and CTO, Endis. Mr. Jim Lai, Chairman of the Board, SkyMiser. Mr. William Wei, CMO and EVP, SkyMiser. Mr. Tony Lin, VP of Sales Marketing, Synposys, Taiwan. Mr. Michael Wang, Associate VP of Corporate Marketing, UMC. Okay, I'd like to invite all the VIPs to raise your right hand and give us a thumbs up to the camera. On the count of 3, 2, 1, smile. Next, we'd like to change our pose. In line with today's theme, RISC-V, let's make a V with your right hand. And let's look to the camera. 3, 2, 1. Thank you so much. Thank you so much for joining us today. Over the past few years, RISC-V Taipei Day has always received strong support and attention from RISC-V International, and it's our honor the newly appointed chairman of RISC-V International, Mr. Lu Dai, would also like to say hi to all our guests here today. Ladies and gentlemen, Mr. Lu Dai.
Hello, fellow RISC-V enthusiasts. I am Lu Dai, chairman of the board for RISC-V International. I would like to welcome you to the 2023 RISC-V Taipei Day. I want to thank the organizers and volunteers for putting together this wonderful event. You are in good hands, and I'm sure you will have an exciting day of learning and sharing. As this event is co-located with IEEE CASIF, I want to also take this opportunity to encourage those who have not to join us. RISC-V isn't just another processor. It is a whole ecosystem of IP, SoC, system, software. In other words, it involves an end-to-end supply chain and presents a whole new ecosystem. As it is built around an open ISA standard, it is truly a revolution that you simply cannot afford to miss. How many of you have given Advanced RISC Machine, now known as ARM, a fighting chance against x86 back in 1990? Can you afford to miss this boat? I welcome you to join our family of innovators and entrepreneurs. Resistance is futile. Come join the inevitable. I wish you all an exciting rest of the day.
Thank you, Mr. Lu Dai, for the warm welcome. Next, we also have the CEO of RISC-V International to share with us the latest global developments of RISC-V. Ladies and gentlemen, I give you Ms. Callista Redmond, CEO of RISC-V International.
I'm Callista Redmond, CEO of RISC-V International, and I'm so excited to share with you a few thoughts today. You know, open standards and collaboration now underpin the most important advances that we collectively as a society have made in hardware. RISC-V defines open computing. We are, in fact, inevitable. With more than 10 billion cores shipping already in market today, we have unleashed a global potential never before seen in compute. We see this coming out in announcements every day from around the world, from important industry leaders, multinationals and luminaries, as well as startups and governments and students. The potential is unrivaled. We see the best processors coming from RISC-V. RISC-V is really the innovation dream come true. We see this in the design potential that is only capable on RISC-V due to things like reserved encoding space, a single hypervisor standard, and other attributes that allow you the design freedom to really tackle the innovation challenges that you're seeking. And we are building the biggest, strongest ecosystem. The collective investment of thousands of companies and millions of individuals coming together on RISC-V has been the collective advancement and acceleration of seeing this ecosystem come to life. And the analysts are predicting an even brighter future. That future is underscored by new workloads coming about from AI and machine learning. It is coming to us because we're looking for profound processing capability across domains. This future is bright, and RISC-V is tracking according to trend, and this is something we can all together be proud of. That collective investment is coming from so many different stakeholders, from multinationals investing more deeply in their strategies around RISC-V to governments and conglomerates coming together and joining forces, because at the end of the day, collaboration really sets the foundation for all of our independent success. Let's think about some of the success that we're seeing already. In telecom and consumer, we're seeing a lot of uptake around Android and other capabilities that have allowed for that freedom and flexibility, from Bluetooth and wireless to central processing. We've seen this in consumer devices now coming out with the first RISC-V laptop and other types of innovations. We're seeing IoT continue to grow. IoT and embedded are a couple of the areas that really started the transition to RISC-V, and we're seeing more and more evidence of this around the world. We're seeing this in AI and ML as companies from data centers to edge really seek to add increased differentiation to their solutions that they're bringing to market. This is brought about by lots of partnerships around our community, including from important companies in Taiwan. We're seeing this also in automotive. Automotive is growing tremendously fast, and we are on course to capture more than 10% of that market by 2025. This is profound when you think about where we've come from just a few short years ago. We're seeing this also in data center and cloud. Data center and cloud evidence coming from large organizations like Meta, who are using it for AI, from Alibaba, who has been using it in their data centers, and from companies in Asia who are also looking to advance their data center capabilities and their ability to compete and differentiate in an ever-growing market. HPC. HPC is an area of profound investment from governments and local organizations around the world, as well as the research institutes and other organizations that have deep interest in progressing the state of the art. RISC-V really has started in on HPC for several years now, and we're so excited to see more clusters coming to market. None of this is possible without the profound developer ecosystem that is amassing around RISC-V. This year alone, we've offered up 130 different development boards to our community to bring their workloads to RISC-V. This is a testament to not only the ecosystem appetite and the profound interest in running workloads on RISC-V, but also the great efforts of the RISC-V hardware community in bringing these implementations from developer kits and dev boards to virtual environments as a real fast-track, accelerated on-ramp for the developer community. And we're growing. We're growing profoundly fast. As you can see from this illustration, we have vested interest from libraries to design and verification and everything in between. IP providers, software, hardware, you name it. There's a place for each of these stakeholders in the RISC-V community. We've made great progress as RISC-V International together with our members. There is a true contributor culture that is underway here. And those efforts of members from around the world rolling up their sleeves, hands-on code, has allowed us to ratify and bring to market about a dozen different specifications this year, including profiles. These are things that are fundamental to the base building blocks to bring a RISC-V implementation to market. And this is a strategic area of engagement for many of our members. That progress is continuing and to gain even more light with our profound marketing efforts. This is the year where we've had 3 major summits, RISC-V Summit Europe, China, and coming up in November in North America. I am absolutely astounded by the number of announcements that we've seen at each of the 2 summits already, and my inbox is beginning to fill up on anticipated announcements for the November RISC-V Summit in North America. I encourage you to engage. There are so many ways. If you're unable to do those events, we have other ways that we can help amplify your success through blogs, social media, and other unique ways that we can help amplify. This includes webinars and other forums to really engage your customers, your partners, and your end users. That engagement extends to the local efforts at a community level. These, the number of meetups and community organizations and alliances that RISC-V has continue to grow each year. These are very important for us as we continue to work locally and act globally. So that local work includes things going on in Taiwan around the association there, as well as numerous associations that are focused on regional efforts, technical efforts, including things like security, and other ways that we as an organization collaborate with others to get work done and to ensure that there is a reduction in the duplication of any efforts that we each do independently. We also have a great deal of effort going on with our ambassadors and advocates around the world, as well as new training now available in Chinese, and as well as certification exams. So if you are not already a member of RISC-V International, I encourage you to engage with us. Think about how this can help progress your technical agenda, your technical roadmap, working shoulder to shoulder with the experts in your industry. Become one of those leaders, become one of those industry luminaries, and you can be proud of the work that we together do on RISC-V. Think about RISC-V as, goal number one, ensuring our member success. Our role in this community is to help enable commercial and academic progress, and that's something that we take very seriously. So talk to us about how we can help support your success, whether it's through skill building or through amplification of the work you've already done. Thank you so much. Enjoy this conference. Use this time to build your network, to find new partners, new customers, to engage with your peers, learn new skills, and go deeper into your RISC-V strategy.
Thank you, RISC-V International. We appreciate your long-time support. Next, I'd like to invite Dr. Philip Tomsey, technologist and founder of RAW, who flew all the way here to share his insights in bridging the divide, unifying RISC-V through binary translation. Please welcome Dr. Philip Tomsey.
Good afternoon. Some of you may know me, especially if you're working in RISC-V. I'm a board member at RISC-V International. I've been running the software horizontal committee for about 3 years now. And I've been, since the start of this month, the vice chair of the technical steering committee at RISC-V. And I will be talking about an important aspect of RISC-V to you today. So we've already heard some of the great things that RISC-V is about, how we are building momentum, gaining adoption. But between the lines, there is a lot of work to be done. And one of these aspects of RISC-V that is making it so successful is also sometimes proving a challenge in the adoption. So RISC-V is building momentum. It's being adopted across a variety of application areas: data center, automotive, artificial intelligence, you name it. We've heard before that one of the strengths of RISC-V is the addition of custom instructions, the pick and choose between the various extensions that we have, the ability to customize your core to your application. Now, that means that we have a number of unique selling points in RISC-V. We can really evolve our capabilities. With the global community that we've just heard about, there is a number of standardization groups and a number of in-flight standardization efforts going on at all times. We have vectors, vector crypto, matrix. So we are constantly evolving. We're addressing the new challenges that software and applications introduce for us. The technical working groups at RISC-V are adding new instructions, are adding new capabilities that define how we can address future challenges. At the same time, we're scaling to your application needs. So RISC-V is not like x86. You go there, you pick the processor. Or like ARM, you go there, you pick the ISA, and you can only implement exactly what is there. You can't leave anything off. You can't add anything in. RISC-V scales. And finally, RISC-V is innovation at a global scale. RISC-V has member companies from all over the globe contribute their specific know-how. This gives us rapid evolution. This gives us new instructions that address a number of new challenges. But what does that mean? So how does that look in the real world? Because everything that's good also throws a bit of a shadow. So RISC-V, just over the last 3 years, has evolved with a tremendous pace. Frankwell showed the slides before, with all of the new specifications that we have ratified and released, all of the new functionality that you can, in theory, implement on RISC-V in a standard way. So just the highlights, the really big ones, the ones that affect software a lot. We have a vector extension since 2021, a scalable vector extension that rivals what ARM and x86 have. We have bit manipulation extensions, but that is extensions. It is not a single one. We have 4 distinct bit manipulation extensions that address various parts of the workload that allow you to do address calculations more quickly for array accesses, or maybe do a CRC calculation in a quick step. A scalar cryptography extension has been ratified in 2021 as well, the hypervisor extension. And as we go on like that, 2022 was mainly about software-driven specifications that did not reflect that much in extensions. So no new ISA instructions, but rather how do we use this? Interoperability specs with one major exception. And that was code size reduction. A large number of new instructions that comes in to make your code smaller, that affects how your binary looks. And finally, 2023, a brilliant year for the number of new extensions. We just had Vector Crypto, one of the most heavily awaited for extensions ratified. Vector Crypto adds cryptography for the high-end, for the data center, on top of our Vector extension. So now we have two different crypto extensions, the scalar one and the vector one. Applications and also chip developers can choose which ones to implement and which ones to use. Similarly, additional floating point instructions in order to optimize the number of workloads. And finally, last but not least, conditional execution. So what we're seeing in RISC-V is that as we are penetrating additional markets, we're identifying gaps. We're identifying optimization potential, and we're addressing it in standard instructions. At the same time, that means that our chips are becoming less similar, more differentiated. Vendor A may have certain optimizations, vendor B may have a different set of optimizations because they are targeting a different market or applications. So, at the same time, RISC-V is gaining adoption. And the goal for all of us is to gain even more adoption for a very simple reason. The more applications we have that RISC-V has been designed into, the more chips we sell. Better return on investment, or as Frank Will said, profit. So if we want to make a fortune on RISC-V, if we want to strengthen our economies, if we want to strengthen our companies, it means we need to find a way to take RISC-V into the applications, to sell the actual chips. And that means we need a way to manage this differentiation. So we need to be differentiated to better compete. We need to be differentiated to win those design-in slots. Yet it is a challenge because our chips are a little bit less similar. So at this point, we have a simple solution, one that has been around for a long time, which is binary translation. So in other words, the ability to run binaries that are not exactly targeting this chip for two reasons. We can take software that was written for one of the other established architectures, put them on the RISC-V core for quick adoption, or we can use this to mask some of these architectural differences. So if we're adding new features, we can dynamically recompile. We can pick up optimizations over time. Or at the same time, if we bring software that has been targeting a different set, maybe a set of extensions that we aren't implementing anymore because they don't benefit the specific application market, we can mask that and dynamically emulate these instructions. So this enables us to address a wide variety of markets. So binary translation has been mostly associated in the past with mobile. So you're in a mobile environment or a desktop environment, and you want to take applications that have been written for a different processor architecture and lift them over. Apple has done it twice. So their migration from x86 to PowerPC was driven by binary translation, and their migration from PowerPC to ARM, actually it's the other way around, it was PowerPC to x86 was the first case, and then finally from x86 to ARM was another successful case of binary translation. It was so successful that I actually even forget what order they used the processor architectures in. So for RISC-V, this is a technology that can benefit us in a wide number of applications. We have smart cameras. These cameras may have been originally designed with an ARM CPU, with some AI libraries in them, with individual features for image recognition, where the source code might not even be available, or where a vendor has licensed a software version that is no longer supported. With binary translation, they can pull it over in the data center. Again, legacy applications. Industrial is usually dealing with drivers, with infrastructure that is not readily available at runtimes, as well as client computing, where in mobile and on the desktop, you actually have the simple case of an application that was sold, isn't supported anymore, and you want to move over. So, as part of what we're doing in RISC-V, we've been asking ourselves the question, how do we want to address binary translation for RISC-V? There have been a number of proposals. A couple companies have been knocking on the door and asking whether this would be something to address. A couple of research institutions have been bringing this up. But binary translation is a well-understood, well-known, and mature technology. So from our perspective, this should be just as open as RISC-V. So in order to address this, we have, and I'm announcing today, initiated a new initiative, the Open Binary Translation Alliance. It is similar to RISC-V, that it is trying to bring companies together that are invested in this market in order to have one common shared platform for RISC-V binary translation, or multi-ISA binary translation, in fact, that allows us to share the infrastructure, to not duplicate, and build on this for further optimization and support. The benefit behind all of this is we're having open collaboration again. We're having pooled resources. We are not wasting the resources and the effort by doing the same work twice. Instead, by collaborating on this key technology, we can pool our resources, we can get to the target faster, and we can continue adding. As we're adding new extensions, we can also add new support for RISC-V extensions and make the backend faster. So what is this Open Binary Translation Alliance doing? We're having 3 pillars. The first one is an education initiative. As I said, binary translation is a well-understood technology, yet we are not training enough engineers. Building the talent, working with the universities, making sure we have the talent to advance this is pillar number 2. Pillar number 2 is the development of a common open source infrastructure that remains open and available. All successful past binary translation products have in fact been closed source. They are done once, they're gone after the translation, after the transition has been concluded. For RISC-V, this is something that will be around to stay. And finally, there's outreach, empowerment, making sure we're building an ecosystem of companies that can build on top of that. So, given that we're coming to the end of the allotted time slot, I won't bore you with the details. We're at the stage of actually gathering the membership. So the development effort needs funding. The funding comes from members. Right now with this alliance, it is started. We're gathering the membership. It's similar to how RISE was founded, the other initiative that is a companion to RISC-V that you've seen. And the goal is to finish up that work by the end of this year. And after that, there is a development time plan building on a prototype that will see a first initial developers preview release next year and the first customer ship possibly as early as 2025. And to conclude, I'd like to show you one quick demo that has actually run on a RISC-V board. And this is an ARC64 and ARM binary running Cormac with a binary translation prototype on RISC-V, on a softcore board, and basically giving seamless execution at near native performance. So, to conclude, please reach out to us. If you're interested, if you have products that need binary translation, join the Alliance so we can have this companion solution to RISC-V that is open and collaborative instead of reinventing the wheel over and over again. Thank you.
Thank you. Thank you so much, Dr. Philip Tomsey. Next, let's welcome Mr. Wei Han Lian, Chief CPU Architect and Senior Fellow Architecture and Test Torrent, who is going to share with us Scalable RISC-V for digital transformation. Let's welcome Mr. Lian, please. Thank you.
So the topic I'm going to talk about today is scalable RISC-V architecture. So why the scalability is important? Because this is relative to this digital transformation we actually experience now. So what is that? Before I dive into tensor and CPU and then AI architecture, so let's take the moment of the time, right? Recognize this is a very remarkable era in the human history. Right? So what we're actually seeing today is that maybe a couple hundred years later, people were actually looking back this period of the time, right? And then looking at this as a new industrial revolution. This revolution is characterized by the human intellect replaced by machine intelligence, right? The first industrial revolution is recognized by the human labor is replaced by the machine. So this is just how significant this era is. So one special thing about AI, what it can bring you is actually this called personalization, right? Which cannot be achieved before. So through the personalization, AI can actually customize everything for you, right? From your personal medicine to afford your kids with a personalized, affordable education for you. However, this kind of personalization requires huge amount of computation. And that's why most people you're here today talking about AI, right? Because this insatisfiable personalization requires huge amount of computation power. So how do we end up to today, right? So how we actually arrived to this historical juncture is through this transistor inventing, right, on 1947. And there's two parallel threads actually being evolving, right? One is the personalized connectivity driven by the internet, and then you have the 3G connectivity on year 2000. And then the next one will be personalized computation, right? Going from mainframe computer to personal computer, all the way to the Apple actually inventing the mobile computing. And that's where the juncture of the time, through the personal connectivity, you have very powerful computation associated with you every day, everywhere you go, right? And then that effect is actually generate this huge amount of data, right, collected about your daily activity. In 2010, there's a called gold mining on the data, which is called data mining. Concepts actually emerging, and that's driving the neural network development on 2012. And that, after that period of the time, the AI computation just accelerate, the model development accelerate, and until the ChatGPT today you are seeing. So this is a picture coming from OpenAI, right? It tells you that on 2012, the AI model is accelerate its computation double every 2.5 months, right? It's accelerating in such a rate that given the semiconductor advancement, right, there's no way to actually meet this demand because more law saying that you can double your transistor every 2 years and maybe 3 years now, right? So there's no way you actually can meet in this computation demand just by through the technology. And that's why rethinking about architecture, right, how to solve this problem is very, very important. And then the other thing actually developing is that model size is growing exponentially, right? So GPT-3 is 300 billion parameter, ChatGPT-4 is rumored to be 4 trillion parameter. And then coupled with the huge amount of data being generated today, right? Statistics show that 2.2 times 10 to the 18 number of the byte being generated every day. So these two powerful events happen, right? Acceleration of the AI model, computation requirement, and also huge amount of data generated every day, they colliding together and generate this perfect storm for the new invention on the AI computation hardware. So we believe, right, Tensorion believe is that you have to solve this problem. You cannot solve this problem by sending all the data to data center. You have to solve this problem distributedly. That means you have to solve the computation by doing AI everywhere, right? So while you define this architecture, you want to be scalable so that it can be applied to on the client side, on the edge side, and all the way to data center using one architecture to solve that problem. Because you actually enable you have a consistent software model while there's a minor change in there. And so why the RISC-V is important from that point, because RISC-V give you a standardization through the ISA semantics, right? So you have standardized tool chain to do that. While the extension, you can customize, you can do whatever you want, give you that flexibility on the customization, which is required for solving this AI everywhere architecture problem. So Tensorion, right? So founded 2016, the mission is actually building the AI, processor, right? So our CEO currently is Jim Keller. So Jim Keller has been Apple, right? Digital Alpha processor, right? And then Tesla, and also Intel, AMD, right? So impeccable record about industrial achievement. So we already have 2 products, right? So Grayskull and Wonho in production. We are working on the 3rd tape out, right? So I'm actually joined the company 2.5 years ago, trying to build this high-performance RISC-V processor, right, to make a heterogeneous computation environment. So this is our architecture. Right, so the first 2 generations, you can see that the first generation is more like proof of concept chip, right? So you're using the PCIe, you can see the regular structure in there. It's called 10-6 core, right? And then you're building with a NOC, and you're building one chip, right, with a lot of AI computation. The second generation, we start looking at the scalability, right, which is important for the high performance computing and data center compute, because you can use the same element to do to scale out and then solving a bigger problem. And 3rd generation is the black hole. We're doing heterogeneous, because heterogeneous is using for solving the problem which unforeseeable future if your AI accelerator has been designed for specific algorithm and you don't have a way to fall back into, right? And then the 3rd generation, now I'm actually working on leading the definition is actually the chiplet, right, architecture. This is another level about scalability, right? Because the problem we are solving need to be everywhere. Sorry, this is I keep touching it. You need to be everywhere, so this scalability make you a composable system, right, to solving different kind of problem. And this is our 10-6 element. You can see that there's actually a 5 embedded CPU in there, right? You can see the CPU is using RISC-V CPU. This is the flexibility we talk about using the RISC-V. Right, and you issue the extension instruction to our AI accelerator, right? So each of the CPU has a particular responsibility in there, and then this tiny element in there is actually the fundamental of the building element for the AI accelerator, and you can replicate it many, many times, right? To building the computation device which your application targeting for. So this is the scalability of our AI architecture. And then you can see that our system also scale, right? We're using Ethernet, talking to the Rocky, right? We can build in this 32, car machine, right? Solving the data center training problem by using to the Ethernet. So scalability, again, is important. And then you can see the strategies that from the IP perspective, right? So our partner can requesting the smaller IP, composing it together and building the exactly form factor and PPA requirement for their application. They can also using our chiplet, right, using a composable element, building the system required for their PPA. And then system chiplet can also further scaling out using the Ethernet technology. And we have the system scalability on the scale-out system on the system as well. So we talk about scalability about hardware, but also software is also scalable, right? So the software will actually enable you to equip with the functionality that actually can take the PyTorch, translate into implementation, right? Let it out in the computation device all the way from one single 10-6 core to multi-thousand chip system, right? So this is the software stack effort, try to match in that strategy of the scalability. So we talk about the scalability of our AI solution, and how about the CPU, right? So CPU is also an important part of the compute because a lot of general compute in any system you are looking at. CPU is actually serving a foundation to booting operating system. But in the AI field, CPU is also serving as a pre-processing, post-processing computation device, but also using as a way to run the application which AI is not doing well. Right? So it's really a powerful backup system for any AI algorithm not executing the matrix multiplication engine. So our high-performance CPU, which is on the right? So on your right-hand side, is actually an AYD machine. It's designed for competing with the AMD Zen 5. Right? It's a really high-performance server-grade processor. So at the same time, we actually make sure that this design can parameterize, right, to support 6Y, 4Y, 3Y, DY decode machine, right? Through this way, we also have a scalable RISC-V roadmap can companion with our AI processor, right, for different level PPA application. We also building a CPU chiplet, right? Each chiplet in this here is actually a 32-core system, right? High-performance CPU core system, and you can compose them together to build like 32-core server, 64-core server, 96-core server, or 120-core high-end server. And this can be serving a foundation associated with the AI chiplet, which I'm going to show here, right? Building a heterogeneous system, right? So you can have a CPU chiplet, AI chiplet, and a memory chiplet and an I/O chiplet. And then give you an example about the composability on the CPU chiplet system, right? So you can have CPU high-end server, right, composed with DDR channel. Then I say, okay, the memory bandwidth is not enough. Let's go to HBM. And I just replace the memory controller, right, with the HBM controller. Then I have a high-end system for the server, right? This is just tell you the scalability and composability of our system, chiplet system as well. So in the following couple slides, I'm going to give you an example where our application is, right, for using our technology. Like our D2, right, chip can be using in the wearable system, which require extremely low power. And then we can also go to the mobile market, which require big or little, right, configuration. So we have high-end server-grade processor can be implemented as a bigger core in the mobile compute system. We also have a medium core system can be used as a low-power efficient implementation for the mobile system. And then for the car, right, so we can have using our IP, right, using L2, L4, inference design. We can also using the chiplet, the customer can choosing our chiplet and put in their associate SoC function on the other chip, right, compose a car self-driving system for themselves. So the strategy is actually using the IP, scalable IP and also scalable chip system, enable us to building a wide variety of systems based on the car requirement. And then we can also using our chip, right, to build in networking, storage server, and also using for the DPU, right? So we have a lot of customers asking for this kind of configuration as well. Video codec machine, right, so associated with the CPU server and with the video encoding and decoding, right, transcoding design as a video codec market. Right? So you just tell you like this scalable strategy worked really well to all kind of application and fulfill our requirement for the computation everywhere for AI. Right? So this is just give you some couple examples demonstrate that the powerfulness of the architecture. So in summary, right, so what I actually presented here is our complete strategy, right? So we believe AI, right, the computation has to happen all the way from client, edge device to data center. It's impossible to solve this problem by funneling all the data information to the data center to create an architecture like that. So you need a computation, right? Efficiently execute at the edge, and then at a high performance requirement to saving the time computation at the data center. And our architecture goal actually fulfill that. So repeat that again, right? So TensorRT offer you scalable technology, right? And then AI is scalable, CPU is scalable, and our chiplet system is scalable. So this complete strategy really helping you to creating computation everywhere, depending on where you want to land your application is, right? So that's my talk. Yeah, thank you very much.
Thank you very much, Mr. Wei-Han Lin. Next, I'd like to invite Dr. Charlie Su, President and CTO of NDIS, to come on stage and share with us on extending RISC-V intelligence from cloud to edge.
Good afternoon, everyone. Extending RISC-V intelligence from cloud to edge. So this is another AI-based talk. So everyone probably heard a lot about LLM, large language model. So ChatGPT took the industry off guard by releasing releasing an application and acquired over 100 million user base in just 2 months. So 2.5x faster than the previous one, TikTok. So they serve a generative AI application in the cloud. But since then, there comes Llama, Alpaca, Vicuña, and Guanaco. So what do they have in common? There are 5 of top 10 open source LLM since ChatGPT started. And they all grown in Andes Mountains. And this including Llama and Llama 2. So 2023, we see the fast rising of open source LLM triggered by ChatGPT. So either it's foundation model like Llama 2, or fine-tuned model based on the foundation. So they drive the edge ecosystem for on-device generative AI, like IoT, smartphone, smart home, and vehicle. So because in the edge, you want to have much smaller database, so can reduce the storage and also computation. And on the hardware support side, Transformer is driving the AI in the cloud as well as in the edge. So not only matrix multiplication, but also important computation like softmax, layer norm, Julu, and their variants. So, but AI is not just LLM, right? So, for example, Transformer can also use elsewhere. Like 5G, 6G base station, people already are looking into using machine learning with Transformer model to greatly reduce the cost and quality of CSI, the channel state information, which is very important for the whole quality of the communication system. And Transformer is also used to adapt it for the ADAS, autonomous driving, and also AR/VR. And SSD controller company, they are looked to leverage machine learning for computational storage. And many AI applications still can benefit a lot from the good old CNN model. So if you look at this picture, so intelligence is everywhere, but they all come with a wide range of computation requirements. It's from over 100 TOPS in the data center to just a little around like tens of MOPS and endpoints. And RISC-V is for all computing devices. So we don't want to leave everyone out. So we want to cover everything. So in the following, I'm going to give a couple examples of how RISC-V is used by different applications. For example, in the endpoints AI, Renesas has a voice control ASSP just running at 100 megahertz and using the DSP capable processor, which can speed up application by just 50%. That's enough to drive the application. And they work with a company which is our partner too, Cybron, which they are the voice recognition expert. They been doing this for quite some time using a traditional approach, but then since machine learning start, they can transfer to machine learning and provide even better quality. Space Touch, the SPV60 is an intelligent audio processor. So they provide not only higher performance DSP processor based on RISC-V, and also come with over 100 gigaops MPU for noise reduction, echo cancellation, and holding suppression. So that's much more computation there. And they also has micro DSP for the FFT and arctangent and log and so on. So their application is for intelligence, voice, smart earphone, and professional audio. So this is bring the computation to the next level. So this morning, we heard a lot about computing memory. The Homo H30 is a CIM-based SoC. So their macro together provide over 256 TOPS with INT8 format and in a chip. So they use standard SRAM-based CIM macro, and that's kind of with an array of that and pack into the tensor element, and that come together with a vector processor, RISC-V, and also their spatial functional unit and shared memory and that can construct into a tire. And that tire can replicate in many copy of them and form the IPU. So that depending on their application total requirement. So this is a standard SRAM-based CIM. And there's also analog computing memory by a company called Tetraman. So they are actually quite expert on this field. They have quite a few IEEE fellow, and they have paper accepted by Nature for their invention there. So their advantage is that they can provide very high TOPS per watt performance. So in this case, 256 by 256 meg, it can go up to 30 TOPS per watt. And that is just to do the matrix multiplication type of computation that is associated with their so-called MPU. But the remaining computing power, they still need a vector processor and general purpose processor to control it. And they leverage that on the RISC-V processor. And Lightintelligence is an optical company. They're using optical not just to share and transfer data, they're also using optical to do the computation, to do MEC. So they use that to accelerate, again, the matrix multiplication. But they also leverage a bunch of the RISC-V vector processor to do the floating-point computation. And also they're using custom extension to help orchestrate the whole system for things like mailbox management and so on. So Meta, MTIA, is Meta Training and Inference Accelerator. Earlier, Frank also mentioned, they published academic paper, ISCA, in this year. Let's talk about their first generation silicon targeting for their Meta's recommendation system. So their process element architecture is based on a scalar processor and a vector processor, and also with a bunch of the additional feature that aided, like I believe some of them moving the data, some of them doing the metric computation, and also spatial transformer type of operation is done there. So one thing which is very important for the reason to choose NVIDIA processor here is their additional function require a special custom extension from the processor, so that from a software perspective, is it all software. So an AI compiler can manage that much better. So if you're using interrupt-driven approach, it won't be easily generated by the AI compiler. So and the same, the PE basically replicated in this particular first generation chip, 64 instances of that, so that totally 128 processor. Okay. So from the above, I'd like to use a general architecture for AI accelerator to kind of cover that. So it's a scalable architecture, and it can separate decision for the control as well as the compute. You can choose that separately based on the requirement. And on the top level, you have global memory, you have a control processor to run OS application and control the cluster. And you can have one or more cluster, and each cluster can have multiple PE. So the interesting thing part, it is from processor perspective, is the PE. So in the PE, they always have hardware engine covering metric multiplication type of operation and other specific function. If it's transformer, it would be a couple of things I mentioned earlier, softmax, Jelu, and so on. And it still requires a powerful compute processor, general purpose, with a powerful vector or SIMD processor to do all the algorithm required involvement, because things continue to change, especially for the machine learning today. And there's also require high bandwidth memory system so that you can have efficient data exchange between the compute processor and the hardware engine. So you can also use this the P itself as a simplest configuration for the just one processor will control everything, right? For the very endpoint devices, probably one processor is good enough to run application and do the computation itself. So, so what is RISC-V architectural advantage for AI? The first is it's come with a very flexible RISC-V vector extension, which cover all the basic computation with high data rate. Even though there's a metric multiplication hardware to accelerate maybe 80% of computation, and to the transformer, it probably become 50%. But there's still a lot of continue evolving algorithm require different computation. When you tape out, you cannot think of that. So it's always good to have the full set of features there. And the next one is extensibility, which allow RISC-V to address ever-evolving requirement. That's when you know it and you want to hardening it. So you can hardening to speed up key transformer operation, like a couple we mentioned earlier. And you need to have efficient control and also data transfer with the external accelerator. If you already have that, and as the data continue to kind of increase, the data format people kind of choose is smaller and smaller, and with the algorithm adjustment to keep the accuracy. So bflow 16 with a full set become more and more important, and asked by more customers that we know, is more than just multiply and add. And also with the extensibility, if standard is not there yet, and FPA is something which all vendor can adapt themselves. So like I mentioned earlier, instruction-based extension, the computation, will simplify the complexity of AI compiler. So that's why all the advanced developer, they prefer to adding instruction to the processor, or other than just have the accelerator put on the bus. And for the endpoint with low data rate, the RISC-V is SIMD DSP or P extension draft, is very effective, like I showed earlier. So NDIS is a RISC-V founding and premium member since 2016. So we are active on the RISC-V or different activity. We are over 18 years old. We established before RISC-V was in the lab. And so that's why we have a lot of customers. We have actually close to 500 people now with office worldwide. And our customer together ship over 13 billion SoC with NDIS processor embedded. So we have a series of product from 2-3 stage compact series all the way to 13 stage all-the processor. And each cover different application category, like embedded control, which deep inside SoC, custom program it, and then they ship it to the system company. They don't even see the processor. To compute acceleration processor, like I mentioned earlier today, it's DSP, SIMD, vector, and so on. A Linux processor, and also functional safety. D25F and is a SIMD processor I mentioned earlier to cover some endpoint application earlier. And NX27V is our first vector processor, and actually also RISC-V's first commercial vector processor. But we have a follow-on here. X45 MPV is a 1024-bit RISC-V processor. It's already some customer. So it's a stage dual issue and up to a coherent cache coherence Linux capable core. But the most strong part is on the vector extension. It's supporting all the standard format and also int4 and full bflow 16. Its vector length can go all the way to 24 bits with 1-to-1 or 2-to-1 ratio to the data processing length. And even though it's dual issue, but it can have up to 6 DRAM results generated per cycle. So that allows the compute bandwidth. But what about handling with external hardware engine? So there's two ways our customers like to use. One is we call NDIS streaming pool, which is through the NDIS custom extension framework, which can facilitate efficient control and data transfer with the hardware engine. And the other one is more traditional, so which just provide high bandwidth vector memory interface. So the CPU and hardware engine can access in parallel. So it's a multi-bank SRAM with special protocol designed specially for vector processor. So in the MobileNet V1 is based on HVN without any special instruction. So in the 512-bit configuration, it's almost 5 times over 128-bit Cortex-A53. And the 1024-bit version would be almost AX over the same processor. So earlier we talked about NDIS custom extension. It's our framework to create new instruction to speed up computation and control. And we extended to support RISC-V vector style instruction, which is on this vector processing unit part, along with the standard instruction functional unit. We're adding the functional unit to handle custom instruction there. So it can take all the same RISC-V formats, the vector length, all the different control, and to execute instruction. So a couple of examples of using this called RVV acceleration. For sine cosine, we can get up to 18x speed up over the pure RISC-V vector instruction. And exponential can speed up up to 3x for softmax. And then also matrix multiplication can go up to over 12x over the standard RVV instruction. And it's also very useful for the complex multiplication. It can get over 6x over RVV. So for all this stuff I mentioned, it's under the same framework solution we call NDIS AI. NDIS AI run everywhere. So it's hardware software solution to provide AI application from edge to the cloud. So on the bottom is all the hardware processor we support, and the far right side is MTIA is our hardware accelerator. And in the top, you can take any model and go to our NN pilot, which can do the pruning, quantization, and optimization, and do performance estimation. And you can speed out your POC code and go to our vectorizing compiler, or generate a model, and then go to the standard TVN or TensorFlow, and then go to the LVM to connect to our hardware. And also very important is, and this custom extension can generate the hardware to go with the processor. And in the software part, it can also generate all the vectorization required information to enhance LVM, so that custom edit instruction, if it follow our format, can be auto-vectorized as well. So with this, I hope everyone can step forward and work with us to bring AI everywhere. Thank you.
Thank you very much, Dr. Charlie Su. Next, we have Mr. William Wei, CMO and EVP of SkyMiser, to come on stage and present trends in AI and automotive, personalization, privacy, data protection, and LLM on RISC-V. Let's welcome Mr. William Wei.
Well, I don't want to play Bloomberg technology. I was testing. First, I have to thank the host here helped me set up all this complicated, more interactive presentation. My name is William Wei. Yeah, my name is William Wei. I have a long journey from a software perspective. I was trained in system software background. I used to work for Apple for 12 years before I came to Taiwan 3 years ago. And in Taiwan, I stepped into the new field called automotive, having a lot of fun. And after that, I found this the best compiler company in Taiwan, if it's not in the world, called SkyMiser. So I just recently joined them. Today, I want to share with everybody here about AI and in automotive, where my experience for the past 3 years with the recent AI trend. So when I was young, I entered this world called web. So web first. Everybody was in the browser, HTTP, all this. Everything is focused on building the web, from the infrastructure, from Cisco to the stack from the Amazon to the browser, right? And we spent like 10 years until we get into the, at that time it was Apple, 2007, and then mobile first. Okay, so all the application moved to mobile. So everybody used the mobile in a way that is different from the web, the user experience, right? Now, today we have AI first. So everybody wants to put the LLM not just in server, but today I saw a lot of Taiwanese company focus on put it on device. And not to mention this year, when Apple Watch and also Siri has what they call on-device Siri, which is on-device local inferencing, right? So everything is geared toward AI first. And we are in the juncture, the very beginning juncture for this journey. So from the perspective of the value we want to squeeze in, it's all about, in the human history, it's all about exchanging energy. Like we burn a lot of energy, we put a lot of effort, compress for a value that we want. For example, blockchain, we a proof of work, we burn a lot of energy for blockchain. For what? For trust, because we need this decentralized trust, right? And then for AI, for the past 6 years, everybody aware of ChatGPT. Everything burning is for what? For intelligence. Something you go in and come out with a task that it just finished to summarize everything, right? So you can kind of seeing all the trend. It's all about energy, right? So I need to start from not 20 years ago, but this past year, about generative pre-trained transformer, which is brought by OpenAI, ChatGPT, that brought the world attention. So we focus on this topic, we focus on model-centric ecosystem. See, RISC-V is all about building ecosystem, right? And then now, when you talk about model, not a lot of people talk about CNN nowadays, right? Everybody is talking about LLM, all this foundation model. But it's more general. Now, with this foundation model, our development, our software stack, turned into another paradigm of development. It's called fine-tuning or context learning. All this fine-tune, try to squeeze even more into this intelligence, right? And then want to put it on device. Like what Mr. Lin just now, scalable from the AIoT to the server, need to be scalable, but sort of LLM everywhere. And most important, if you want to put it on device, what it concerns is, what about your private data, right? You don't want to send all the data to OpenAI, ask them to train for you. You want to, for enterprise, you want to keep your enterprise secret on premises. If not on the edge, at least on your premises. So this domain data that nobody else have, you want to keep it. And last but not least is the security and privacy. So later on, we'll talk about security a little bit and also privacy. How do we do that? So just now we mentioned inferencing, on-device inference. Today, we don't see a lot of on-device inferencing. Probably the latest Apple Watch, the chip they have on-device inferencing, series on-device, but I don't believe it's the end game here, because the user experience, it's not such a disrupted, okay? We used to be living in a mobile-first world, like you flip your phone, you kind of search something, you want to do something, and then you do it yourself. But in the future, maybe if it's intelligent enough, it's all about task completion. You don't need to scroll around. So on-device inferencing is gonna, this is just my projection. I look through the internet trend and then see this on-server inference to the on-device inference to 2032. This is a trend that I'm observing. And then another thing is what I call public general training data to private data, even to the federated training, which on-device distributed, they can train together and get smarter every day, right? So this trend, I think, is gonna be kicked off by the community to explore all this solution to protect your data. So let's take this kind of full life cycle of this training. You have genetic LLM, which is GPT, Llama 2, Cloud, Qualcomm, all this. It's trained on public internet data, right? We have this. It's already performing quite good. You can do summarization, all this, the killer feature, but it's limited. So from now on to the future, everybody start looking at what if I use my domain data, right, to train? And you can train from scratch, which is very expensive, or you can train based out of the model size or foundation model you choose to train with, right? In the future, you're going to have education domain GPT, climate GPT, right? Government, right? You can have city or government. 3 years ago, I moved back to Taiwan. There's a lot of government interface I have to go through, right? Visa, everything. And it's kind of spin my head, Googling everywhere, try to accomplish that. What if Taipei government is a Taipei GPT? You just chat to it, say, hey, I'm here. Help me go through all this a single window. In the future, each government have this chat GPT just solve all your problem, right? Automotive, where I spent past 3 years on. And then you have this domain-based, but still for personal, it's kind of generic LLM. Then you can fine-tune with your personalization, all the data. You fine-tune it, you make it smaller, you can put on your own device. Not necessarily your smartphone, although everybody, without any imagination, you say, oh, okay, I want to put it on my cell phone. But coming from Apple, I don't think my DNA tell me not going to be the same form factor of LLM on device. Maybe you have some kind of energy pack with you, and you have computation and intelligent core with you. And your user experience, your other application, not necessarily on your cell phone, right? So after you fine-tune all this private data on device, this requires a lot of compiler technology while you're inferencing. How do you do with all this data to train become your own personal GPT, your city GPT, my car, right, GPT. So again, it can be, okay, all this can be, it can train private data from directly genetic. So software is getting fragmented. That's why recently you have Chris Lerner come up with modular AI, try to solve the fragment software stack, fragmentation problem. You have IV, try to solve the backend compatibility problem. SkyMiser is in this game, by the way. So call for reunification. Software-defined chip is what everybody is talking about, using domain-specific purpose or application-specific purpose. But it's software-defined and software hardware co-design is different concept. Software hardware co-design is software give hardware some hint, and hardware give software design some feedback to co-design an ASIC, a special purpose future chip. Now you have AI SoC. Pretty soon you have LLM SoC, right? Hardware is, I'll just skip this. All these domain-specific hardware. So RISC-V come to rescue, right? There's three. One is an open instruction set. It's customizable. It's royalty-free, right? Cost is insecure. Why is secure? Because it's open. Everybody can, just like Linux, everybody can expect it, see what's the bug. So at the end, it's going to be more robust. And low power and scalability. This, Testoran already have all this in the previous session. And then again, everybody here for vibrant community. This is what RISC-V need, a vibrant community to improve the rapid innovation, global standard collaboration. Right? So to recap, we coming from the general purpose computing, which everybody talk about flops, tops, right? All the CNN stuff. But now, if we use LLM-centric computing, then it's memory bound. This for computer science is memory bound. It's all about how big the memory you can do. What's the bandwidth that you can ship all the data. So at the end, it's all about in-memory AI. This is one of the trend that I observe as far as the LLM. So first of all, move compute to data, right? How do you reduce data movement? And how do you increase the size and data bandwidth? And all this for the risk community to ponder around. Automotive, the last, we know that this year, the 6 months of this year, in US, Tesla outsold everybody else combined, right? So Tesla is what everybody chase after. What is it about Tesla? It's all about software-defined vehicle. So what is software-defined vehicle, right? Tesla has FSD. It has a brain. A traditional automotive has no brain. It's just ECU, no brain. So if you are building a computer system with a brain, you got to put in OS, you got to put in real-time OS, RTOS. You got to build up the middleware, service layer, right? And then on top of the service layer, facing the community, you need SDK, you need API, you need the domain, EV, ALM, right? And then traditional application can come in, and the new application called AI agent, Copilot, can come in, right? So in order to build this, we need all this stack. Today, automotive has no such stack. Tesla has, but it's close. So the gateway for other disruptive tech force to enter automotive is to build this and open it. To open it, what I call Android of EV. So 2 years ago, when I came back to Taiwan, I helped started MIH, what they call Android of EV, the open platform for EV kit SDK, 2020. And then everybody know Eclipse Foundation contact us at that time, and they started the software-defined vehicle working group in 2021, Eclipse. ARM approached us, say, hey, they're coming to launch what an open community for all the ARM instruction set. It's called Sophie. So they started in September 2021. All this trend, and last but not least, the AutoWare Foundation started what they call Open Autonomous Driving Kit. And the last what I talk about is in the software, we see a trend to end-to-end, right? End-to-end meaning you don't code, you don't hand code anything. You don't understand how it put it together, but it just works. So traditionally, we have this modular, deterministic world of modular design. Have a full-state machine that you fully understand, and you use code to glue together to become application. End-to-end, all the AI communities go into end-to-end. You input something, go through the model, compress all the intelligence in this model, and come out with task completion. In autonomous driving, mean drive, safety. So autonomous driving, I put 2 examples. One is Waymo. They are modular plus code, glued together. Right? They have LiDAR, they have all the different sensor fusion. And for one community called Open Pilot and Tesla release 12 is end-to-end now. So here on the left side, you have multi-sensing. When you have multi-sensing, it can be really complicated. You got to do a sensor fusion. After sensor fusion, you pump through some CNN, many CNN to get a perception. You get object detection. And then you start coding some planning. How do you drive? How do you avoid? And then at the end, you drive, you control. So a lot of human code there. And then on the right is input vision data, model, and drive. On this map, there is Open Pilot's map. The latest map is a mimic human being. The model look at you feed model this navigation, and the model figure out how to control to go to the destination. So they don't even know how it drive, but it's end-to-end, it drive. So robotic, again, Boston Dynamic, modular, same thing, modular approach, and Tesla, end-to-end, right? There's some video. Let me just show one if you didn't. This is last week. They announced this last week, the latest model. So they only use vision. Even the joint control, they don't know how to control it, but the model learn how to control it. So you get the idea. For Boston Dynamics, it's really good too. I mean, it can do a special task. I don't know why internet doesn't play, but let's skip it. This is 1 year old anyway, Atlas. So new AI experience, it's different from deterministic application AI experience. Traditional application experience, like everything you install on your iPhone, everything it's information retrieval, and then you figure out what you want to do. But LLM, all this is fine-tuned. You just tell it what you want to be done, and it's done. It's called AI agent. This is new AI experience, right? So you can, for example, you can put the whisper, voice, and then you can have this open interpreter. And then you have this LLM. And the end of day is like Star Trek, right? That's Star Trek. That's end-to-end. New automotive experience. It's EV LLM, and you fine-tune it, and you become AI agent. This AI agent help you drive, help you open the window, whatever. You just talk to them. So this is voice, open interpreter. Open interpreter basically automated to compile a source code program for you dynamically and then complete. So if everybody old enough, everybody know the Knight Rider kit, right? This one, right? Bill. Well, you get the idea. So it goes through, with this brain, it goes through the CAN bus. CAN bus in automotive is a standard. It's a nerve system, it's a bus to pass around a lot of command to tell how to put on the torque. A lot of the ECU control use CAN bus to communicate. So with AI coming in, it will disrupt like from the distributed ECU. One car, right now, modern car is about more than 100 ECU. It's all distributed. It's a dumb ECU, no brain. So software-defined vehicle with the CAN bus, it put this stack in with the brain. Then above, all the application developer can come in to innovate your new automotive experience. This is open interpreter. You can get online to see Hugging Face. Basically, this command is that, can you set my system to dark mode, my Macintosh, and then you figure out to set the dark mode. This is very interesting. This is I tell Bart, say, okay, this is my car is a Toyota 2022 RAV4 hybrid. So I tell Bart, say, go to internet and read all the thick manual, technical manual over there, and then help me accomplish some task. And I say, turn on the fog light, turn on the windshield wiper in the auto speed mode, turn on the FM radio, turn on the ADAS for highway driving, and then unfold my side mirror. And it go read the manual and shoot all the commands that need to accomplish those tasks. So in the future, automotive doesn't need to give you a owner's manual. You just talk to your car, say, what do you want to do? Just confirm it. So the race to build a software-defined vehicle, it's all about the brain. It's all about this AI SoC, so software there can stack up. And then, by the way, automotive world always talk about functional safety. So this is one of the implementation of architecture that satisfy ISO 26226 with a deterministic module handle safety, functional safety. Just like AI, you need alignment, you need guardrail, right? So this is a deterministic guardrail. It know all the safety functions. So when AI try to control this car, it will check and see if you do it. Last is the commercial time, SkyMiser. SkyMiser is a software-defined AI SoC compiler company. One compiler for all architecture. That's their goal. So basically, SkyMiser defines software AI SoC architecture, and SkyMiser has an AI runtime engine to make on-device inferencing and training possible. It is optimized for state-of-the-art fine-tuned model and domain-specific AI application. We focus on production-grade AI model deployment on all edges with compiler-level acceleration software stack and tool. Thank you.
Thank you so much, Mr. William Wei, for sharing with us your insights and research. Okay, thank you so much. Now we're going to take a quick break, and please make sure you take the time to visit our exhibition back in the room and engage with our fellow exhibitors. Also, we have prepared some snacks and drinks outside, so please enjoy and make sure you seize the opportunity to talk to our experts here today. For the next part of the event, we'll start with the lucky draw. It's your chance to win the AirPods and iPhone 15 Pro. So make sure you come back. I'll see you later. The next session will start at 3:40. Please make sure you come back for the panel discussion. Thank you.我们下一个场次的 panel discussion 将于3点40分准时开始，请现场所有的贵宾稍后记得3点40分回到座位上，我们准时开始我们下一个活动，谢谢。 Wait. Good afternoon, everyone. The event is about to begin. Please take your seat as soon as possible. Thank you. 提醒现场所有的来宾，活动马上将于3分钟后开始，欢迎您可以开始准备入座，谢谢。提醒现场所有的来宾，我们的活动马上就要开始，邀请您紧速入座，谢谢。Good afternoon, ladies and gentlemen. The event is about to begin. Please take your seat. Thank you very much. Good afternoon, everyone. Thank you so much for joining us today. The event is about to begin. Please take your seat. Thank you very much. 提醒现场所有的来宾，活动马上就要开始，邀请所有现场的贵宾紧速入座，谢谢。Good afternoon, ladies and gentlemen. Welcome back to 2023 RISC-V Taipei Day. 非常感谢现场所有的贵宾再次回到我们 RISC-V Taipei Day 第2部分的活动现场。 Before we begin our panel discussion, do you have the lucky draw ticket with you? Because it's time for us to draw our winner for the first prize, which is our Apple AirPods 3rd generation. Okay, before we start, please prepare your name card and ID and bring them to the front stage if you win the prize. Now let's first welcome Dr. J.S. Huang, General Manager of Syntronics, our generous prize sponsor. Please put your hands together for Dr. J.S. Huang to the stage. You want to say a few words to everyone? Wait.
Oh, okay. Go.
Okay, before we start, we have the yes. Okay, and please say go when you are ready, and we will use the randomizer to draw the winner.
Ready? Let's go.
Congratulations to winner. Ticket number 135, 135, 135. Is the winner here? Oh man, okay. Congratulations, ticket number 135 to win our AirPods Pro 3rd generation. Okay, please come to the stage and take a photo with Dr. J.S. Huang. 恭喜我们交大的同学抽到我们 AirPods Pro 3代。
35.
Congratulations to the students from University 交通。Okay, thank you so much. And thank you, Dr. J.S. Huang. Please return the seat. Thank you so much. And if we didn't pick your name, don't worry. Later, after the panel discussion, we'll draw the grand prize, which is our iPhone 15 Pro. So stay tuned. Now, let's keep the excitement going and get ready to carry on our panel discussion. First, I'd like to invite our moderator for the panel discussion, Professor Chen Tianfu from National Yangming Jiaotong University. Please come to stage. Next, let's welcome our panelists. First, I'd like to welcome Dr. Philip Tomsey, founder and chief technologist from Veral. Next, Mr. Wei Han Lian, chief CPU architect and senior fellow architecture, TensorTorrent. Dr. Charlie Su, president and CTO Andes Technology. Please come to the stage. Thank you. Mr. Jim Lai, chairman of the board, Sky Miser. Mr. Tony Lin, VP of Sales Marketing, Synopsys, Taiwan. Mr. Michael Wang, Associate Vice President, Corporate Marketing, UMC. Okay, thank you all to our VIPs and thank you for joining our panel discussion. Let's now pass the stage over to Professor Chen, please.
Oh, okay, good afternoon. Welcome to this panel discussion. Okay, so today our topic would be exploring the RISC-V adaptability for AI and automotive. Okay, so let me give the rule. First, I would like to invite all of the panelists to give an open statement within 2 to 3 minutes. And then we already collect a few questions. And I would like to raise those questions for 2 of the panelists. And then we will open the open discussion from all of the audience here. Okay, so basically we will have at least 3 stages. Okay, so why not let's start with Philip first for the opening statements. Thank you.
So I've heard a lot today about RISC-V and also about semiconductor engineering in the first half of the day. And one of the things that stood out to me is that we are still very hardware-centric, still very silicon-centric, talking a lot about process sizes, gate technologies, but those are building blocks today. And I heard some hints at more software-driven innovation. So understanding the applications, co-designing by adding custom instructions. From my perspective, we are continuing on a trajectory with the actual process technologies, with making our silicon faster, but the big innovations are going to come on a system level. So I have as a vision that we will actually design better silicon, more power efficient silicon, not just by improving our processes, but by improving how software uses them and reducing the wastage of cycles, basically. Co-designing, co-engineering, and driving the direction of hardware evolution directly from a better understanding of software.
So I already talked about our vision about compute everywhere for AI, and this is probably hardest topic people are talking today, how to meet in this computation demand for the future AI. Right, so there are a lot of system issue, but the so from architecture perspective, right, the requirements is actually having a very adaptive architecture, right? While homogeneous, while with the flexibility to extend it, and then because this is a RISC-V forerun, I think the RISC-V actually born at the right place at the right time, right? Because you look on the ChatGPT-3 when it's born, before that nobody is aware that the AI has become so powerful. However, AI is just an inception, right? The early starting point of the AI revolution. So there will be a lot of changes happen. So anything you develop in the architecture need to satisfy such a wide variety possibility of the future. And then you need this adaptability in the architecture to support that. And then RISC-V is actually just at the right time meeting that kind of demand. Right? So there will be a lot of challenging, right? Including like, I certainly believe the model we're using, AI model we're using today, is going to go into some kind of changes, right? And I really don't know, cannot predict what's the future. To simplify computation maybe. And the software stack require a lot of changes as well. So like the thing we are actually proposing that we want to do AI everywhere, then you need a way actually to compile your application to distribute the computation everywhere, right? So where is that software? But underlying assumption on the architecture is actually well supported by RISC-V. So that's my statement, yeah.
So extendability is one of the best features RISC-V brought. So it offers flexibility, adaptability when your application are kind of fast evolving, like AI, like automotive today. And itself, we realize the need actually driven by customer. So it kind of very dramatic story. The marketing guy told us that after they tape out a chip, he went to the chip designer to ask, say, if our chip can do this and that. The chip designer looked at his face, saying, "Sure, we can do that. We just do another tape out." Right? So, so that kind of bring them some idea, saying that when they're adding feature, they should not just kind of harden it purely on the SoC part. They want to tightly couple with a processor, especially like instruction based, so that later you can just change the software to satisfy the different market requirements. And when you go to the AI and automotive, that's actually even bigger. So extendability is very important, but also how do you do that? Right? You not just kind of open you can write the whole RTA by yourself and then do a solution. But most people would rather have a clear defined boundary and then do what they kind of good at instead of kind of everyone design a processor. So that what the end is coming to play to provide this custom extension framework to fully utilize RISC-V adaptability.
I'm representing SkyMiser, a software company specializing in AI compilation. So the message I'm going to highlight in my short opening, one is that adaptability, which is RISC-V's one of the important benefits. Another is the software. So allow me to use one of the brief story that since I came from design services industry, let me share with you a brief history of evolution of crypto mining chips and AI chips. Crypto mining chips started with CPU in about 2009, and then quickly replaced by GPU in about 2011 to 2012. And then in about 2014, it was pretty much replaced by the calculation or computation specific ASICs because of the PPAs. Okay, and then in around like 2015, AI applications became to search by using NVIDIA GPUs. So, and later on that led to the expansion of the bigger and more lucrative market, as we all know. Then the crypto guys are thinking about actually are doing something. They are trying to develop another calculation-specific ASIC to repeat the history, to replace GPU in AI application. But this time they failed due to the deployment. It's very difficult for the chip company, for the AI chip company, ASIC chip company to deploy the AI applications without the adaptability and without a very complex software stack. Okay, so, and today, NVIDIA is still dominating the AI chip market. But on the other camp, I think the competition camp is getting more stronger now with all the chip giants and heavyweight startup company like Tenstorrent and others. They are putting a lot of effort and investment into developing a better AI chip with not only the PPA, but also the adaptability and all the benefits from the RISC-V. So a lot of our customers now are adopting RISC-V's core because of the adaptability and scalability and other benefits, of course. But then they will also integrate with other processor cores, including their own proprietary specialized accelerators. So with the hybrid processor of the RISC-V cores and other processor cores and accelerators in a heterogeneous platform, a whole heterogeneous architect, how to achieve the task parallelization becomes a very super complex task for the software. That's exactly where SkyMiser plays a very important role in AI democratization. So again, the adaptability and the software are the keys to the AI chip deployment.
Hi everyone, I'm Tony from Synopsys. I prepared a few slides. It's my honor to join the panelists, and I will my honor to quickly update our Synopsys solution for RISC-V design ecosystem. So very quick. So Synopsys is a strategic members of RISC-V International, especially for Taiwan. So we partner with our RISC-V core providers, foundries, and the university. We do provide comprehensive IP and customization flow tools for RISC-V implementation and verification. So you can see the overall solution from Synopsys for RISC-V design. First of all, you can see the IP provided system design based on your connectivity IP spec, and also we provide the ASIC design for your CPU code architectural exploration, and also provide the virtual prototyping, hybrid, and the emulator and FPGA for early software development, which can help to your software designer to do the software design for the shift lab development. And then we use Synopsys implementation IP with powerful AI technology for implementation. So ASIC, how we can have the how we can do the optimize your processor model. We base on our tool to create the ASIC to provide the full architectural flexibility and also automated generation of SDK and the synthesizable RTL. More than that, we provide 12 RISC-V SVM models. This can be the starting point to accelerate your engineering productivity. For after you leverage our ASIC design, you can have several RTL code base. You can easily to use Synopsys RTOA to do a parallel exploration with auto footprint and the PNR to compare the QOR quality of result. And then let me quickly update to you. Once you decide your RTL code base, you can easy to do the PPA code by Synopsys AI technology. I leverage this example. This is a RISC-V high-performance CPU core. Our target is 1.95 gigahertz based on 5 nanometer technology. The baseline is 1.75 gigahertz. Usually, we need to spend 2 as per engineering by 1 month. But based on Synopsys DSO technology, DSO means design space optimization. We can achieve 2 days. Just use 90 runs with 30 cold star training and 60 one-star runs to get the target by no human interfere. So after we do the hardware implementation, at the same time we can do the emulation to help the OS bring up and software stack development. So overall, Synopsys provide the comprehensive EDA tool, IP, and the reference methodology, enable our ecosystem, enable our industry for the successful implementation of RISC-V SoC for every application. Thank you.
Hello, everyone. My name is Michael Wen, and I'm from UMC, a foundry company, Lianhua Dianzi. I'm very excited sitting down there and listening to all the good presentations that the area that we have. And that was very exciting because I feel like elementary school kids. I learned all the new things I didn't know before. And also I pay attention to where is this a service provider, this a foundry can play a role. And I realized that nobody mentioned anything about it. That means 2 possibilities. One is nobody has any tape out yet. One is they are so good in the foundry service and also the service provider companies like the Synopsys and also all the other service companies there that's transparent to the foundry. And then finally, Philips come to rescue. Then he's the one that asked me, oh, we have a few designs that we want to design on the automotive grade 22 nanometer. So that I can feel comfortable at home right now. So let me flip through a few pages here. And actually, I borrowed this one. See, that's how lack of knowledge that I have. I even borrowed this one from RISC-V International from Miss Raymond over there. So I will skip this too. So we're talking about billions of cores that expected in year 2025 and then 27, and then exceeding 60 billion cores to tape out by year 2030. So what the foundry can offer here, and also I would like to promote and also like to offer our service, just to try to escape what Charlie just mentioned over there, that you have to retape out one more time and wait for a few months and spend $1 million over there, and then don't know how to answer to your boss why you need to retape out again. The design, the process that we have, I think it's just like the software, hardware, you need to co-optimization. The hardware, the design, and also the process, if people can really know how to use that one, there are some minimum requirements that you have to know. And on top of it, if you can think of the design for manufacturability, design for testability, and also the co-optimization between the design, the process, and the design, I think that your first time success rate will be much higher, and then you will really become transparent. When you tape out, and then after a couple of months, then you got your silicon and you got your chips, and then everything works wonderfully for you. So the foundry here, that we have the foundry design case, we have analog IPs, then every chip needs that. And also, if you're working for the embedded non-volatile memory, that's particularly used for the MCU and also for the automotive applications over there. And then those are the additional information and additional design care that you need to put into consideration at the first beginning. Just very quickly go over, these are the technology nodes and also the technology flavors that the UMC is offering in production today. And then from the left, from your left to your right, that's the past 43 years of UMC, starting from almost 0.6, 0.8 micron technology, and now we're at 12 nanometer. So these are considered the so-called mature node. And then how do we make this one more useful for our customers, and is to expand this one into the specialty technology. So the first one is the one that on the very top, that's the large and mixed mode. So we need to have a very good foundation over there, just like the big trunk that you have on every big tree over there. And then you spread out that have all the branches. So here we have the RF CMOS, we have RF SOI, a millimeter wave, embedded high voltage, BCD is for the power devices, embedded NVN, that's for the embedded flash, or the more recently is the embedded resistive memory, RAM. And the memory, computing memory, that one actually could be one of the candidates over there. The CIS is for the camera, the MEMS is for the sensor there, and we have discrete and also the 3D application. So all the chiplet solutions that we are also develop our modules and working with the OSAT to provide this one for all the end chips over there. So this is a very quick rundown for the technology that UMC is offer, and hope that the RISC-V become inevitable, and I hope that the foundry is indispensable, and UMC become the indispensable partner for you all. Thank you.
Thank you. Okay. Yeah, thanks so much for all the panels. Okay. So let's focus the adaptability. I think the Andis and SkyMiser already mentioned that adaptability is quite important for RISC-V, all right? So as we know, RISC-V offers a very good feature in extending the instruction set. So is it a distinctive business model when compared with traditional IP business, just like ARM? So the question is it feasible for the IC designer or any software company to offer the customization service just for the RISC-V only? Perhaps the Andis and the SkyMiser can help to answer those questions. Thank you.
Yeah, Andis is pretty big on customization, but we are providing two ways. One is we provide a so-called Andis custom extension. That's a framework to give customers to do the extension themselves. Because a lot of customers, what kind of instruction they add and what kind of performance they get, that is kind of the secret they have. So by offering the tool, they can easy to do that without have a bunch of people knowing the processor, but just to kind of adding the feature kind of on the peripheral side. So that is, you get a lot of attraction on that, especially on the high-end application like a data center or like high-end AI processor customer do. I would say probably 80–70% of that using our vector processor plus Antis custom extension tool to fulfill what they need to do. The other kind of customization is even more evolved. So customer want to do something beyond the tool can do, and only some special occasion you cannot map to that automatic tool. So we do offer some strategic customer that we do some customizing directly by hand, but that is something very advanced. The important thing is adding instruction just at the beginning, and then you need to take care of the software. So earlier in my presentation, in the automatic customizing tool part, especially for the AI, we're adding the instruction in the hardware, and also we generate the extension component to LLVM so that the compiler itself, taking our component, can recognize the scenario and generate the instruction customer insert in their application or generate from their AI compiler and down to the LLVM, and eventually map to the hardware instruction they added. So software component need to take into account as well.
Great, thank you. How about Jim?
So you asked about any other third-party design service company can provide this kind of customization service, right? So I think this is definitely the RISC-V core vendors' domain knowledge, domain know-how. So they are poised to provide that kind of customization service for the extended instruction set. And as far as the traditional IC design service companies like GUC, Alchip, I don't think they have the necessary domain knowledge about this extended instruction set in order to undertake the customization service. But from the software side, software design service company or software product company like SkyMiser, I think what we can do is maybe leverage the RISC core's internal tool chain and their library, like operator library. We can integrate the library into the customer's SoC, maybe with other libraries as well. Maybe the customers will use other cores, and they may have the same, or they may have similar libraries. Or they may ask SkyMiser to use our compiler to compile directly from the models to the target architecture. So we can integrate the libraries from different core, or we can compile the models to target architecture. And then we can kind of orchestrate and optimize the parallelization. So it's not a customization service for the extended extended instruction set, but we can utilize the library from that instruction set and kind of integrate them and orchestrate and optimize. That's what we can do.
Good. Thanks, Charlie and Jim. All right. So yeah, we know the RISC-V is very promising in the future. Okay, but the market application demands are quite diversified, right? So such like automotive and data center, or even the small core AIoT. So yeah, my next question would be for the perhaps Philip and Synopsys. So do we really have a adequate ecosystem ready for the RISC-V chip industry to face those diversified application markets, and even how to achieve very good system or service to meet those PPA design analysis or software design time to market issues in a quick time, all right?
So I think the answer is it depends on where you stand. So the ecosystem today is better than many fear, but it's worse than some hope. To illustrate that a bit, we have complete Linux systems running on RISC-V. We have AI applications running on RISC-V. So everything you want functionally is there. In some configurations for some vendors, it will be very well optimized already. Of course, we have challenges with interoperability in parts. So the most deployed hobbyist developer board is using the wrong version of the vector extension, a draft one, for example. But those are details. So generally speaking, RISC-V is ready for prime time on software. You have to be willing to live with some of the, or compensate for some of the effects of it being rapidly evolving, it being rather new. RISC-V has made up a lot of space in the last few years. And of course, it could always be better, but we're making great strides there with RISE, with companies that are offering dedicated services. My own company has been working on the standardization of some performance-enhancing instruction extensions as part of RISC-V, conditional operations, additional floating point instructions that are coming directly out of specific workloads, so JavaScript on some of them, specific spec benchmarks. So of course we're improving things. We haven't reached the stable set of RISC-V software not evolving anymore. However, in a way, if we did that, probably RISC-V would be a legacy architecture in that, because the fact that there is work to do and that we are continuously improving and evolving is just showing that it's dynamic, that it's alive. And most of that evolution is coming out of the high volume applications and the interesting applications. So we're pretty ready for data center. Of course, there have been a number of specifications recently around virtualization, IOMMU security, and we're adding new ones to optimize for those use cases. Similarly, and some of the people up here have talked about that today, similarly for AI. So to put it short, RISC-V clearly is ready. We have a very vital software ecosystem, and we're ready for that. And the fact that we're identifying gaps and we're openly talking about them and closing them actually means that RISC-V is doing great, is advancing, and is very much alive and being adopted and picked up for new solutions.
Yep. Quick answer is yes, I think we have, but we need to do more. From Sinan's point of view, I think that the value of the ecosystem is to provide the customer how they can use this ecosystem to tap out or to do the title market as soon as possible. So from Sinan's perspective, we separate three portions. First one is hardware implementation. Two is software development. Three is IP block diagram, how we can help customers to do this design. So for hardware, I think I just mentioned in my slide. So from system to the GDS2, I think the flow can help customer to easy to do and can achieve the PPA. But the software development, I think that currently in Taiwan industry, we still need to strengthen the knowledge or expertise, how we can have the software development before the tip out. Always we want to build a software after the tip out. It will be let the title market slower than before. So Synopsys provide the emulator or FPGA to help customers to do this kind of software development in very early stage. For IP, we did have the pre-verified and the pre-configurable IP subsystem to help customers in different applications. Just like Synopsys has automotive grade IP for automotive SoC, and also low power IP for AIoT. And not mentioned, we also have a UCI IP and other high performance IP for cloud server or AI server solution. Thank you.
All right, good. So yeah, let's follow the discussion of the AI, all right? So can I ask Andy's, what are the really the opportunities in general from the AIoT to such a LLM, large language model? So it's a kind of very diversified and complicated AI model. So what are the real good opportunity for RISC-V? Can Andy's or UMC, Tony, Michael, can also comment on that?
Well, I'm the least qualified to answer that. I think that many speakers have already good presentation there. But I think that from foundry point of view, I think that for us to provide the reliable and then repeatable and also cost-effective solution is our goal. And we have been doing that one for so many years. So I really encourage that. I think that RISC-V will definitely be adopted. And then it will penetrate through many, many verticals. And then the verticals there would really take advantage of the RISC-V's, the adaptability, scalability, and also the relatively lower cost and the more power savings over there. So I think all those are wonderful. And for those to happen, I think that the end use, the vertical end use, need to identify that one. And also take advantage of the well-established foundry, the design service activities over there to make sure that you really have the solution that is good there. Because I think that, just because that this one is a global activity and also there's no centralized, a single company that running behind this one. So it really needs to have for all the ecosystem player come into there and be open enough. And then one of the service, one of the necessary indispensable portion there is the foundry. And the foundry and plus the design service company working together with foundry can really make this one transparent. And then we can do, UMC and also the foundry partners can do the best they could and become invisible. And then every time that your tape out becomes successful. So that's what I'm thinking over there. Is we are standing by to support the RISC-V to become successful.
So can Charlie comment on that? On AI. Yeah, what are the real opportunities for the AI in general? Yeah.
Yeah, and this is big to kind of help fulfill RISC-V's potential for all computing devices. So while everyone talk about LLM, and we do have customer doing the data center part, and there's also another bunch of customers kind of on the endpoint part. And so data center part of the customer, they're probably using like 32 to 64 of our vector processor. On the edge part, they're probably using one, but it's, for example, 1024 bits, so that's still a lot of compute power. And to the even smaller endpoint, which probably 100 megahertz and 4 meg per cycle, that's good enough for them. So we all need to serve that. So what Andy's do is with our Andy's AI run everywhere is to provide a software framework. So from the top, we take the AI model and then go through that optimization and either directly generate code. And depending on whether that hardware is a vector processor, has how many bits of a vector per cycle of computation, or it's a kind of smaller SIMD. It goes through the same flow. So our software infrastructure actually is supporting that. And as far as kind of application is concerned, I think more or less majority of the new application going to have some kind of intelligence. So I do have a big hope of that, right? So.
Okay, good. Yeah, I think let's specifically focus on the large language model. So let me ask for this question for the Tenstoran, William, and for the and UMC again. No, it's for the SkyMiser. So the question is, we see there are lots of interesting applications based on the LLM. But the most currently the LLM is most rely on the CUDA to compute or to train and to inference those models. So how does the RISC-V can help or can offer the opportunity to improve, offer to good chip for those the training and as well as the inference for the large language model?
So first of all, CUDA is just one of the software frameworks supporting AI, right? Like Tenstorrent has its own software framework. And so regarding the role that the RISC-V play in large language model, from my perspective, it actually doesn't matter, right? Because we are trying to build is a generic platform can run any AI well. And then underneath that framework, basically we're using the RISC-V as a control processor to issue instruction to the AI acceleration. So the thing we actually want from the RISC-V is actually that freedom gave to you, right? Without imposition on the law and then also on the architectural licensing, right? Give you that freedom to implement anything you want. Because I use working in the Apple, right? If you want to implement something with ARM, you just go into this lengthy negotiation, get the architectural license, and then there are a lot of restrictions about what you can implement, what can you do. But RISC-V give you that freedom. And once you have that structure you can implement on your accelerator, then basically any kind of model you can run, you can do any kind of special optimization for it, and that RISC-V give you that flexibility. So answer your question is that large language model is just one of the AI application. And then what RISC-V enables us to do is actually building this flexible AI system for any future, AI algorithm. So I don't think it's really a differentiation, but that freedom gives you to implement a better foundation system for the future AI algorithm.
And from our perspective, since LLM is still pretty new, currently we don't have any IC customers using any core to develop LLM yet. But I think in terms of applications, many people are talking about since we focus more on the edge, many people are talking about for example, the robots or the smart speakers, or even cars, like William mentioned earlier. Car is also one of the edge. And whether or not to use RISC-V is something that we are also looking at it. LLM requires very high bandwidth. That's one of the requirement, memory bandwidth requirement. So we are wondering whether RISC-V can manage or can kind of enhance or reduce the memory bandwidth requirement. And I think that would be a very useful core for the LLM applications. And inside SkyMiser, we're also trying to define, like William also mentioned earlier, software-defined engine, software-defined LLM engine. We're trying to use different techniques, software technique, to reduce the memory bandwidth requirement, so that that engine kind of be bundled with the compiler, so we can drive the engine and then interface with the memory. That's the plan that we are working on it specifically for ALM because of the high bandwidth memory requirements.
So yeah, can I add a comment? So one thing I want the audience to know is that from the software ecosystem perspective, right? Any new emerging field which doesn't have a lot of software application burden, right? RISC-V is actually great for that. Like for example, auto market, right? It's a brand new market. There's not a lot of software ecosystem already there. And then RISC-V is actually very good for that because everything you have to start from scratch anyway. And the AI market is the same. Like Tenstorrent is building a completely, ecosystem for the software stack, and we don't have to rely on anybody to do anything for us, right? We're building the whole ecosystem ourselves, right? So that's a great way to utilize this, right? But if you go into the server market, if you go into existing mature market, right? There are a lot of ecosystem around in that, and there's a huge wall to climb, right? So if your application is actually very specific, right, to a certain area, you don't need a lot of ecosystem support, RISC-V provides you a very good platform for you, right? So to starting something from scratch. So to surmounting, right, that the ecosystem wall, right, take a long time. And then, however, this RISC-V just started. If you actually have a very targeted system for the area that you don't need a lot of ecosystem, you have to build your own one. This is a great architecture for you. Yes, the legacy system, yeah.
Okay, good. Yeah. Okay, so let's focus on the RISC-V for the automotive. So I would like to ask Michael, how, since the automotive applications for the automotive require this safety, reliability, and very good, just like a real-time response time. So how can RISC-V to enhance the RISC-V feature to meet those the very challenging needs for the automotives?
I think for the automotive, yes, indeed, that's become more and more important, especially when we starting to have this electrification and also EV business here, just like one of the panelists mentioned, that is really put a brand on wheels, right? And in the future, actually, every car will be like a data center running over there, everything automatic. So putting all this safety, all this regulation, all these requirements into consideration have to consider from the very beginning. And luckily, this one, I think, it should be decoupled from the software layer. So the software can be just like our panelists mentioned over there, can be really focused on how you can extend that one, especially you build from scratch up, right? So you don't really have a lot of burden over there. But on the other hand, that all this hardware implementation, especially to comply to the spec, to the regulation, to the ISO requirements over there, that one, the service, design service company as well as the fab has to do that one. So from the foundry point of view, for example, that automotive actually grew very fast for the past 3 years. So in our company, that's almost close to 10% of our business. And then each of the traditional ICE car usually take about hundreds of ICs over there. Most of them are the MCU. And that's why I mentioned the embedded flash become one of the de facto process that has to be used over there. But in the future, over there, we're talking about thousands of chips there. And then some of the chips are really the brand. You really need to have a 3 nanometer, 5 nanometer to make that really brand useful. But the rest of them, you're going to see hundreds of sensors over there. LiDAR, radar, everything over there. So all those, you need to really take advantage. First, you really need to have a specialized technology to do that. Otherwise, it's not done on the logic process. And secondly, you need to know that where is the good boundary between the software and the hardware, and where is the boundary between the design and the process. So once you have a good separation there, I think the EDA company, Synopsys, and also design service company can do a lot on that one. So from foundry point of view, I think that once you have those separation done and have a good separation over there, and then the reliability, the responsibility getting very clear, I think that should be transparent from the RISC-V architecture. Then that means the RISC-V can really take advantage of its own inherent advantage over there, and then leave the rest of the implementation for the design service company, the EDA industry, as well as the foundry service providers.
Thank you. Yeah, I think TensorFlow already have a good design for the automotive. So can Wenhan comment on that for any features for that?
Yeah, so for the car application, I think the most important thing is actually first is the manufacturing process need to be compliant, right? The second thing is actually they call FUSA, functional safety, right? Functional safety in general from the implement perspective is orthogonal to the original design. So functional safety implication is that you have to comply certain design goal and then meeting the compliance requirement, and in general can be afterthought, right? But what we actually are driving that is that afterthought sometimes make the design too complicated. Like if I design a processor without thinking about functional safety, I have to put in a lot of Band-Aid to satisfy that functional safety requirement if I do that later. So what we are actually trying to drive on the architecture side is that think about functional safety requirement before we actually implement anything. So you make things actually much easier and also make the compliant cost on the hardware implementation much lower, right? So that's where the architecture innovation and on the functional safety, right, is actually a requirement now, because we see in the future of the AI, if you see, we say compute anywhere, the key application is actually interacting with a human being, right? Once that interaction happens, like in the car, in the robotic, right, the functional safety will be key requirement. And if the company trying to gain advantage on the design, right, they need to think about functional safety when they're actually getting on the scratch board, right? So that's very important for the future car or any, you know, functional safety required application. Yeah.
Okay. Yeah. Let's switch to the RISC-V for the data center. I think the chips for the data center would is quite promising in the future, but the chips for the data center require the scalability, very good scalability. Also, it needs a very good software support for the virtual machine, for the hypervisor development. So I would like to ask comments from Philip. How do you see chips, RISC-V chips can be ready for those applications?
I guess I'm standing so close to the efforts to do that I'm probably not going to talk about the big picture because I'm involved with too many of the gruesome things, and if you're standing in the kitchen, you exactly know how the sausage is made. So there's really two hearts beating in my chest on this topic. On the one hand, if I compare it to a typical enterprise server workload, we probably are there. So, and data center is a lot of things. There's network layer, managed switches, firewalling, routing, storage, all of those things, especially when you're getting into these appliances. We probably have everything, and that's also where custom extensions can come in. I mean, what better than custom extensions to take care of your parity checks, your checksum calculations for storage? Most enterprise workloads do not really require virtualization. Many of those will be in classic programming languages. So right now we have pretty much everything running on RISC-V. So you have Go, you have Java, you have basically the entire long list of managed runtimes. Of course, it also took ARM 3 chip generations to get everything just right for the best Java performance. There are very few chips that you can buy today for RISC-V for the data center that have the greatest and latest specifications. So you may find the hypervisor specification implemented, but if the hypervisor specification is implemented, you already have the advanced interrupt controller that will allow you efficient delivery of interrupts into guests. So it's basically different colors of gray once you get into this world. So are we ready for your typical hyperscaler to deploy this? I wouldn't know where to buy a chip to do it, but I believe that we have a large number of companies that are really that close to taping out chips for it. And at that point, the final work for the software ecosystem starts, because even as we have the latest and greatest atomics, hypervisor, all those fancy blocks like the advanced interrupt controller and IOMMU in the silicon, then we also need to make sure that the software is optimized and tested. And a lot of that optimization is actually happening once it's deployed. So yes, we are certainly ready. We may not be able to replace every application that Xeon can serve today. But we're ready for the data center. We can get real volume there. And as we have the volume, we can also make sure that we are a very good architecture for it, because part of the appetite comes with eating there. So once we have the applications running, there's going to be more optimization work, more feedback, and the next generation is going to be better. But this is the first community-defined, open instruction set architecture that is very quickly maturing to go to the data center and even add values there that some of the established architectures didn't have. When I think of confidential compute, security, all of that is being addressed very quickly because it is a lot of great minds contributing to specifications. And the first generation that is here today can address a lot of problems. The generation that is taping out today is going to address even more. And in a year or two, or maybe if you're a pessimist in 3 or 4, this question is going to be a shrug, and the question, why did we even ask it a few years back? Because it's just going to be so normal to have RISC-V in the data center in 2, 3, or 4 years.
Okay. Yeah, can Tony comment on that, how Synopsys?
Yes, scalable data center, I think it's related to heterogeneous design. Actually, a few years ago, I delivered the heterogeneous design update in Semiconductor Taiwan, and a few data points here. Top 3 for the heterogeneous design is data center, mobile, and automotive. Top 3 process node of heterogeneous design is N5, which includes M4, N5, N7, and N12. But the connectivity IP is N-1 or N-2. So overall, we see the heterogeneous design or scalable data center, you need to focus on, you want to invest more in the advanced design technology. The investment is huge. But the other data center, other chips, I think that our RISC-V can also contribute more. For example, GPU tray, BMC, Smart. I think that that's the chips we can also invest our RISC-V technology in this technology. Yeah.
But yeah, we still have a few minutes, so I would like to invite any questions from the audience to raise Charlie's question or any question for the panelists. Okay.
I find this is Inzhe Huang from National Sun Yat-sen University. I find the topics of this panel quite very interesting and challenging in that the average car lifespan is about 12 years. But consider now that we'll talk about the customization, configuration of the hardware, software. So replicate, you can customize your hardware and software for a particular function. So how are you going to make sure your software and hardware still functioning after 12 years? Considering the fact that the average lifespan of a smartphone is about 2.5 years. So in this regard, what I'd like to hear from the panelists. Thank you.
So I have a perspective about this, is that the future car, right, how will need to be upgradable. Right? It's like a system, right? So the car maker today, they try to make the most money actually not from the car itself anymore, actually from the function provided by the information system in there. And therefore, the differentiation on the computation is extremely important. So when they design the car, they actually ensure that the system, especially on the computation, is upgradable. So it means that you might be buying a car with the lower end of the self-driving system, and then on the other side, people will pay much more to get the L4 self-driving system, right? And therefore, that system is already upgradable, and then that means in the future, they should be continually able to upgrade their software and the hardware, right? So even in like 12 years, I think you still can get the latest hardware as long as it's compatible to the upgrade system.
This is really a question about software and software life cycles. So mobile is going the path of, okay, this is discontinued, buy a new phone. That's not going to happen on cars. And it's not always going to be an option to replace the compute system. So yes, replacing the compute system is one of the options, but in many cases, we're going to see a maturing of the software processes. So car makers today are really bad at software. Even the ones that are good at software are really bad at software when you compare it to enterprise software companies or classic software companies. And what we will see as a paradigm shift is going to be more software lifecycle processes, configuration management, automated testing, and configuration points shifting into it. In other words, you have a software update, but depending on the car it gets loaded in, certain features will become available, certain add-on functionality that may not be available everywhere. For example, because the sensor suite doesn't get updated. So you have quite a complex device that needs to configure to the peripherals that are available. And RISC-V, to get back to the RISC-V story, is actually offering a very interesting perspective there, because I remember discussing ARM cores with rolling stock on the railroad in France about 15 years back, and their biggest concern was how long will the chips be available. With RISC-V, they can actually take control because it could be their own chip. So an automotive company can affect that and can have long-term availability of a specific core that they can use. So yes, it's a software problem, and RISC-V is actually helping to make it better by enabling more control over the cores for the integrators. Thank you.
Good. So why not let's take a last question there. All right.
Thank you. Hello everyone, panelists and host. Thanks for the discussion. And my name is River. I'm the student from National Jiao Tong University. So my question is quite open-ended and simple, which is, for our young generation, what is the recommended path for us to join the ecosystem of RISC-V and AI? And also, how can we create promising value to this ecosystem? Thank you so much.
This is an interesting question. I think there are multiple paths, but first path, maybe you can join Andis. You can send your resume to us. That is assuming you are interested in what we develop, a processor and processor ecosystem. But there's a lot of other stuff there, which is kind of part of the RISC-V, like for example, SkyMiner doing higher level AI compiler, our good partner. So that's also something interesting, also along the way of AI development. And there's a specialized AI hardware accelerator, maybe very low power. You can, based on the model and direct generate the hardware itself. You don't even need processor. I know there's something like that. So that's another path you can kind of go into. But just kind of speak for Andis. So what we cover is the processor programmable, and also cover kind of the fundamental compiler, and also kind of from AI and also from the process perspective. So you kind of provide I think enough wide range of interesting stuff you can kind of doing for your lifetime.
Okay, one more minute. Okay, Jim.
Yeah, can I add something from different perspective? If you are interested in the core processor, core hardware and software, I think Andis certainly is a better or one of the good choice. And if you want to look at from this maybe SoC level, higher level, that you kind of oversee the heterogeneous integration, I think SkyMiser will be a good choice for you.
1 minute, Philip, please.
I mean, besides the fact that you can also submit your resume to our company, there is one interesting trend, and that's open source, and open standards. So join an open source project, see where you can contribute. Start by doing the gardening work, analyzing bugs, reproducing, contributing. It's going to make you a better and more visible software engineer. Do the same on the hardware side. So join RISC-V. It's a free membership. There are specification projects going on, and these always require proofs of concept. So you can learn by doing, and you can build your profile. So it's really join any of the open source initiatives out there, hardware, software, get going there, learn, build yourself up.
Yeah, perhaps you have some experience. Sure.
Yeah, I just say that download it, join the member, and work hard, and then and do contribution, right? Like Philip said, right? Build your profile, get people aware of you, right? That's the most important for you. Yeah, once you get that status, right, and you are actually making a great contribution. So yeah, just work on it.
Okay, good. So the time is up. So I will appreciate all the panelists, and thanks for you all attending so far. Thank you. That's the end of the discussion here. All right?
Big thanks to our moderator and panelists for this very insightful discussion. Now, may I invite you to come forward to the stage. Let's take a group photo. Okay, let's move closer. Look to the camera. On the count of 3, 2, 1. Thank you. Okay. Yeah. Okay, thank you so much, our moderator and panelist, for the discussion. Okay, and before we wrap up the event, we do have one thing left unannounced, which is the winner of the grand prize, the iPhone 15 Pro. Small reminder, please prepare your ticket and your ID or name card when we call your number. Okay, before we proceed with the draw, let's once again welcome Mr. J.S. Huang, General Manager of Syntronics, our generous prize sponsor, to the stage. Okay, in the meantime, our randomizer is ready.
Are you ready?
Yes. Excited.
Go!
Congratulations to number 1. Is number 1 here? Oh, it's over there. Okay, please come to the stage, and we will have a photo with Mr. J.S. Huang on the stage.
Number 1?
Yes, it's over there. And while we are verifying the ID, I'd like to take this time to give a special thanks to our sponsor, congratulations to David Lin from Zhonghua Telecom to win our prize. Okay, please look here. Okay.
Yes, number 1.
Number 1, please look here to the camera. Okay, thank you. Congratulations to Mr. Lin. And thank you, Mr. J.S. Huang, for sponsor the prize. Okay, thank you all for joining the event today. I'd like to take this moment to give a special thanks to our sponsor and partners, including PowerChip, Andes, SkyMiser, Synopsys Taiwan, UMC, MediaTek, National Sun Yat-sen University, National Cheng-Kung University, National Yangming Jiaotong University, and National Tsinghua University. Once again, a big thank you to all attendees. If you would like to stay updated on the latest of RISC-V, feel free to scan the QR code on the screen and join RISC-V Taiwan Association for free. And please keep an eye on our official website for the latest updates. RISC-V Taipei Day, look forward to seeing you again next year. Thank you.
法兰克在吗 ？Frank。